of energy and save power. Yes, we have developed a project, our faculty member with the help of a student project, develop a project for automating switching on and switching off of corridor light. We have a very long corridors, hundreds of lights are there, so that is connected through a device designed by our electrical department with the help of as a student project. Automatically whenever light is required it will switch on, and in the morning it will automatically switch off. No need to wait, watchman will come at 7 o'clock or 8 o'clock, put off all the light. Installation of moisture sensor lighting system in classroom. Normally what happens, a student goes to lab or from one classroom to other, they forget to switch off the light. Light is still glowing, so we have developed a project. In fact, our principal is devised this mechanism, this project, and tell the classroom student only. They have developed and they have installed. Whenever people will be there in the classroom, your light fan will be on, and rest of the time it will be switch off. And it is very much necessary to conduct time to time awareness program on energy conservation. Next. Next. So this is all about the energy conservation. Next, come to regarding energy efficiency. So we have replaced almost all the LED lights, incandescent light, fluorescent tube light, replaced it LED light. Almost 100% we have completed. Using, yes, star rated appliances wherever possible. In air ACs, old ACs has been replaced with the star rated inverted ACs. Existing fan, this project we have just taken up. Whenever we replace the fan, we are going for BLDC fan. Its power rating is just half of the normal fan. And maintenance, regular maintenance, we have a huge team of maintenance with the trainees. Time to time we just greasing, oiling our this fan bearings. And we install a daylight system, sky lighting, installation of daylight system in classroom. Just show the, yes, you can see in this classroom there is no tube light, but a daylight system we have installed. No need to consume any power, no need power supply. Sunlight will be diverted into your classroom. This project we have done in top floor. Similarly, we can made in the second floor or ground floor also. So sufficient light we will get without wasting its power. And this project was developed by our electrical, one of the faculty member, and installed. And whenever you visit our building, academic building, you can have a look. It is a very good project. Next. Yes, sir. Rainy season also we get some light, but not that much of sunlight. Well, water will not come. It is covered and it is through mirror and this tube, it is so made, all the sunlight you will find in the classroom. And another thing is we have constructed a building, Island First green building awarded by IGBC, Indian Green Building Council. There you will get all natural light, airflow is there, where circulation is there, there is minimum use of, we have not installed a single air conditioner there. With the help of fan, we get comfortable in the classroom. Next. Next. Yeah, this table shows reduction in energy consumption at deep rate. So this many lamps we replaced with LED lamps. Next, next, no? Next. Yes. So we have replaced altogether 936 lamp. We have replaced with LED lamp, and total saving per month energy consumption unit wise 6,317 unit is got reduced. If we multiply with the rate of tariff, so we will get 90,000 plus amount we are saving per month. Next. Solar panels. In our all building, wherever structure is supportive, we installed 4 solar panels and 2 panels is under installation. Worcester Mechanical Building. Next. Yes, this is the calculation, sir. Energy generated through solar panels. So just I have taken the readings of 4 months, March to June, and through solar panel we have generated this much of unit of energy through solar panel, and our institute consumption I have noted down. You may find we are almost self-sufficient to produce energy, but these panels were installed by the private party, so this benefit we are not getting. In the later days, if you install our panels, so we will be self-sufficient in energy also. So with this small presentation to our best practices, what we are following here in our institute. If you ask, if you have any questions, sir, so I will be happy to give on. And moreover, I request all of you to suggest some more measures which we can add here, so that we can show how an institute can be self-sufficient in energy aspects. Yes, sir. सर को माइक दे दो. हाँ, yes. In solar panel only cleaning of panel surface is needed, for which we are developing a system. It will be clean mechanically.
But when others are giving, you are not benefited.
Others, they are getting all power and they are supplying to the electricity department, and they are charging from the electricity department.
Same amount.
Same amount. So we are not getting any benefited. We have provided only our space, only our rooftop.
But if we provide, any subsidy will be getting from electricity department?
Yes, definitely.
Institution comes under
Commercial also. Yeah, when we install our panel, so we will use our power. No need to give it to the grid.
Yes. Thank you, sir.
Sir, Kudu? Yes, sir. Yes, sir. Please.
Just for information of the house over here, IGBC is a CII body.
Okay.
So it is our this thing of, and it made the first green building in the country in Bangalore. So that is where they are housed now.
Okay, sir.
So if you're looking for new technologies and new ideas of reducing your
Energy
revenue burden, and not only energy burden, even every other aspect of green building. You are aware of that. You just said most of it. Beyond that, any other consultancy and all that is required, we can connect you with them.
Sure,
In fact, today we have a speaker from IGBC.
IGBC. Okay.
Yeah, Mr. Kiran Anand would be talking.
Okay, sir.
So if you want, they can
Yes,
advise you on whole lot of
We will have a
green building work.
one-to-one session also with him
Yeah.
if he is here.
No,
Today-
he is
tomorrow-
online today. Unfortunately, he could
online.
not travel.
Okay, okay.
So
Or students, basically students. Yes, Arun sir. Yes, sir. Arun sir is my predecessor. Yes, Arun sir.
I want that our mechanical department, vehicle section, we are having many old vehicles which still we are using. So you don't have any plan to take EVs, electrical vehicles, replace them, I think, for our vehicles. So if we can take that also, it will be better. This is my suggestion.
Yes. Actually, we have initiated a proposal because till now administration is purchasing EV vehicle, electric vehicle and provided to head of the departments. So we have already initiated to get a vehicle, EV vehicle. It is proposal is under consideration since last 6 months. I have seen in file. Yes, we have all, many vehicles are very old and consuming lot of diesel as well as polluting the environment. So we will certainly go for the electrical vehicle. Sir, ex-superintending engineer, yes. Yes.
So my name is Sushmit. I'm from CII. Just have one small question, which is, do you have any way to gauge how much renewable energy that you're consuming and how much non-renewable that you're consuming?
That calculation we can do, sir, because we have installed meters, energy meters, smart energy meters in all the output or input places. So that data is readily not available. As I shown in my last slide, we are producing almost equal amount of energy which we are consuming. But unfortunately, we are just supplying it to the electricity department, and benefit, we are not getting any benefit. The private firm, those who have installed this solar panel, they are getting the benefit.
Okay. But then we are still generating.
We are still generating, we are still taking power from the electricity board, and we are paying around 3 lakhs rupees per month.
Okay. Thank you so much, sir.
Sir, good morning, sir. Good morning. Sir, just for the all audience, Mr. Manohar Singh is ex-superintending engineer and stalwart in electrical field. Although he is a mechanical person, but he have equal knowledge of electrical. Here we are talking about electrical, na? That's why yes, sir.
Good morning to all. One or two slight clarifications.
Yes, sir.
You said you are taking good initiative on energy efficiency,
Yes, sir.
right? Putting LED lights, BLDC fans, etc., etc.
A small initiative we have started,
Good
sir.
initiative. Very
Yes.
good initiative. Very good. We should appreciate that. It is commendable.
Thank you, sir.
We should appreciate that. What is the saving in units because of these energy efficiency initiatives with reference to earlier consumption? Are you having a data, sir?
Yes, sir. That data was shown, na, sir.
No, earlier maybe you were consuming a lakh of unit
Yes, sir.
originally without this.
Yes, sir. That data is there.
No.
Go to the previous slide. Yes.
And plus what is that data? One is in units, another is per student strength. Suppose there is a student strength of 1,000 in an institute, na?
Yes, sir.
So how much per student energy
Consumes.
consumption has been reduced?
Okay.
That is one standard application
Okay.
of the energy reduction in or energy efficiency
Okay,
or
sir.
energy conservation.
We will definitely calculate.
Kindly, if it is possible, provide.
Yes,
this to us.
yes.
Secondly, then there is a 330 kilowatt of solar plant, rooftop solar plants. I
Yes,
think,
sir.
na? Which is generating around 6,000 units per month, saving around a lakh rupees of bill.
Yes, sir. Yes, sir. Around
Is
97.
it meeting your complete 100% power of your institute, whole institute, I mean to say? Monthly consumption of the whole deep breath institute is only around 19,000. Next page?
Next, Major. Next slide.
No, you are showing somewhere.
This one.
19,000.
Yes, sir.
Nine.
Yes, sir.
So this only 18,000 units are being consumed by the deep rate per month, total.
Yeah,
Hostels,
excluding, sir, residential.
okay.
Hostel is included, sir, in this
Hostel,
figure.
workshop, academic classrooms, all
Yes, sir.
included. Okay.
Everything is included because that data we have get from the electricity bill, sir, for which we are charging.
Okay, okay,
Yes, sir.
good. That is very good. If you could give us some data sometime regarding the total saving vis-a-vis earlier consumption and after your energy efficiency.
Efficiency is, yes, sir.
Thank you.
Thank you, sir. And we'll calculate, sir, per student consumption of energy, what you told, we will calculate and we will see. Earlier it was, okay, sir. Thank you, sir. Yes, sir, please.
After class is over,
Yes, sir.
all the students, they leave like that, lights are on, AC are on.
Yes,
You
sir.
can't have any centralized control. Nowadays, CCTV all is there.
We have installed CCTV. Through CCTV also, that is one of the way. If you made this connection like that, so we can control from the CCTV rooms also. After seeing nobody is there, we can
Yes,
switch
switch
off.
off.
Yes, that is a
That's
good
what,
suggestion.
because you are telling that a lot of energy get waste because even the classes are over. The
So
lights
moving
are on.
sensor, initially we have installed moving sensor in one of the classroom
Oh,
as a
very
pilot project. So your suggestion is also good. If CCTV who is seeing all the thing, he can control from CCTV room itself.
Yes, yes.
Yes, sir.
Okay. Thank you.
Thank you, sir. Good suggestion. Students, I am inviting electrical student at least. Mechanical, electrical students are there. I am within the time frame, na, Sajita? Exceeded, okay. Thank you, thanks a lot. Anyway, sir, thank you, sir.
Shankar sir, your talk has set the tone for the event. Thank you very much, sir.
It is a kind request to all. We have a separate discussion and question session at last. Please have any sort of question, queries. At last we have a session for that. So, and all the speakers, please stay here till the last, end of this presentation, so that you can answer any queries or whatever the discussion is required, you can please. Thank you. Now to share the energy security of Andaman Nicobar Islands challenges and possibility in the archipelago, let's welcome Ms. Deepa Nair, Executive Engineer, Electricity Department. Her insight will shed light on the unique challenges faced in ensuring energy security in our islands and explore potential solutions. Please.
Respected dignitaries, officers of respective department, CII, and in the archipelago. First of all, let's have an overview of electricity department. As you all know, electricity department of Andaman and Nicobar administration is the only entity responsible for power supply in this union territory. We are working towards operating and maintaining power generation, transmission and distribution network in these islands for providing electricity to the general public. Power requirements of these islands are met by own generating stations as well as through power purchase agreements. Due to the geographical and topographical peculiarities of these islands, including separation of sea by great distances and absence of single power grid, powerhouses at various islands are independently to the power requirements of the area. Next, we will go island to island basis and see power availability in the different islands and the power demand of the region, which is met through different generating sources. The South Andaman is the largest district where the peak load is 45 megawatt and the installed capacity which is we are having is hiring owned departmental DG sets and through power purchase agreement modes. So during daytime, the entire load that is 30 megawatt, which is met through 60% of solar and 40% of DG. In this, I would like to add that the hiring DG contributes a lot during the generation, which is met by solar, own departmental DG sets, that contributes only 5 megawatt out of 45 megawatt. Whereas the hiring DG contributes a lot, that is totaling to 35 megawatt. And solar contributes to 29 megawatt, and all these are through 20 megawatt of ground mounted solar power plant installed by NLC at Dollyganj and Antapad, and then NTPC 5 megawatt at Gyaracharma, and remaining rooftop solar power plant totaling to 4.15 megawatt. In North Andaman, we have DG based power supply, and including this, we have one hydroelectric power plant that is the capacity is 5.25 megawatt hydroelectric power plant, which is on Kalpong River. It adds to the day load, that is 100% of day load is met by this hydroelectric power plant, whereas the peak load is met by 70% of hydro and 30% of DG. Rest all the islands are being fed by hired or departmentally owned DG sets. We don't have any renewable energy source as of now in the remaining islands. Like Swarajdeep, we have owned DG sets and hiring DG. Owned means departmentally owned, and the peak load is 3.8 megawatt and the day load is 2.2 megawatt. In Little Andaman, including the Dugong Creek area, where we are having installed capacity of 3 megawatt, peak load is 2 megawatt, whereas the day load is 1.5 megawatt. In Nicobar group of islands, we have Car Nicobar, Tarasa, Chaura, Kamota, Kachal, Champion, Campbell Bay. Here the installed capacity totals to 8 megawatt, and the 100% of peak load and day load, both are met by DG source only. In addition to this, the electricity department is providing power supply to the tribal hamlets in Great Nicobar. Point number 8, we are providing power supply to the tribal hamlets of in Great Nicobar Islands and Nankori group of islands also, and some isolated pockets at Bangaon, Hanspuri, Rutland, Smith Island, like that. The Smith Island is in Diglipur, North Andaman division. These all are fed by 100% of DG power supply. As we can see, all these islands are running on standalone mode, and a dedicated management is required to maintain and run the generation and transmission system for providing reliable power supply and services to the consumers. Of course, there are many challenges, but broadly we will look into some of the major issues. as the power base significantly relies on hiring powerhouse and different locations in South Andaman with operation control on private entity, remote monitoring and supervision of these power plants for synchronizing into the system by the department is a major concern in the absence of an integrated auto control system. As the power base significantly relies on hiring powerhouse at different locations in South Andaman and supervision of these small power plants into the system by the department is a major concern due to the absence of an integrated auto control system. Frequent variation in power output from the existing solar power plant due to cloud movements and intermittent solar irradiance in the South Andaman grid has been hugely impacted, leading to major power disruptions in Port Blair and adjacent areas. This grid instability situation is only because of the absence of an adequate storage solution to absorb the solar output variations from the 20 megawatt NLC power plant. Apart from this, the available power infrastructure for transmission and distribution of power is mostly in dilapidated and old condition, and most of these are running beyond their service life. So, frequent system deficiencies are encountered and their maintenance and repair requires considerable time, and hence restoration of power interruption due to the line faults in the affected zones takes longer duration. The department has not expanded over 4 decades, and therefore the present organizational setup is not commensurate with the increased consumer base and power demand. Power availability is largely based on several number of DG set running together, so breakdown of any DG set results in power deficit leading to load shedding, as the situation always remains hand to mouth and is not able to mitigate any contingency. Lack of awareness in consumers on judicious utilization of power makes the demand side management plan a failure. Main reason for present power crisis at South Andaman is the drop down of 50 megawatt LNG project envisaged to be commissioned by 2022. There are numerous steps which are being taken by Andaman and Nicobar administration to tide over the crisis, which includes many power projects and other plausible solutions. We will delve into some of the future power projects and which are in distribution infrastructure and which are also in the pipeline. Under the scheme Greening of Islands, Andaman Nicobar Island is envisaged to establish solar power projects in all the major islands. That is, first one is 118 megawatt ground mounted solar project which is to be established at Mithakadi, and then Stiwatganj, the Swarajdeep 3.8 megawatt, Little Andaman 5.7 megawatt, and other Nicobar group of islands totaling to 10 megawatt. The solar projects are adequately combined with battery energy storage system of corresponding size and capacity. Andaman Nicobar administration is working with SECI for finalization of land and other approvals and clearances for establishment of these plants by 2026. This would enable transition from conventional based projects towards sustainable power solution, aiming to enhance the energy security of these islands. It will also contribute in our commitment in the direction to achieve net zero in the power generation sector. Under this, next one is saturation of rooftop solar. Here, saturation of rooftop solar in all the government buildings, residential has been mandated by the Government of India. As per the directives, all the feasible government and residential buildings are being considered for installation of rooftop solar. Here, the 30 megawatt rooftop solar in residential buildings, we can see it has been, SECI has been roped in for implementation of 30 megawatt rooftop solar in residential buildings by MNRE. And NVVN has been assigned, and they are also in the process of floating of tender for 3.45 megawatt rooftop solar in government buildings. In addition, under the grid connected rooftop scheme phase 2, MNRE has shared a draft tender document wherein we have empaneled 3 vendors for installation of rooftop solar in all the categories like commercial, government, industrial, and residential. All these sectors can be covered under 2 megawatt RTS in for government buildings. Actually, the tender was for 5 megawatt, but however, we could find a capacity of 2 megawatt only, that too in government sector. Here we have the tender for 25 years, and now this 2 megawatt rooftop solar will be installed in 181 government buildings. Since we didn't get sufficient consumers for residential sector, the cost of the cost which have arrived through tendering process is 1.5 lakhs nearly for the category 1 to 3 kilowatt. So it is not much invited by the residential sector. However, this step has been taken as an initiative to enhance energy security and reliability by enabling these buildings into self-energy sufficient to meet their power requirement. Next is the storage solutions. Now let's see how does the need of having storage has arisen. Solar generation is intermittent. So in order to have a constant power flow in the grid, this needs to be regulated to avoid grid variation. South Andaman grid has an infusion of 29 megawatt solar power, but the available storage is not sufficient. Hence, to develop an adequate support, a 20 megawatt hour BESS project is likely to be commissioned soon, so that the solar power can be optimally utilized and grid stability can be maintained to avoid any power disruption situation. Apart from this, 15 megawatt hour BESS project on energy shift arrangement sponsored by JICA, that is Japan International Cooperation Agency, they have been roped in, and in coordination with Ministry of Power and Andaman Nicobar administration, these projects are in pipeline. This would absorb the surplus energy in daytime and shall be utilized to deliver power at peak hours. Next is the pump storage project, which is being envisaged at the existing 5.25 megawatt hydroelectric power plant, and NHPC has been roped in, and they are assessing the pre-feasibility so that the hydel plant can be run during off-season as well. Next, privatization of power sector in Andaman and Nicobar Islands. Under Atmanirbhar Bharat Abhiyan and in line with the decision of Government of India, privatization of power distribution utilities along with the embedded generation is being done in the UT of Andaman and Nicobar Islands. The main objective of privatization is to bring in professional management and to enhance operational efficiency in the power sector and to reduce the overall AT&C losses in the power system. The bid document has been finalized by Andaman Nicobar administration, and the bid shall be invited at the earliest. As the proposal gets approval of Ministry of Power, bid shall be finalized. Last is the expectations from industry. There is a lot of expectations from industry, but given the limited time frame, I would like to highlight few core needs. Due to highly subsidized power tariff and higher cost of rooftop plants, it is seen that the consumers are not much attracted to adopt rooftop solar plants. So the participation of industry would be very significant to bring in more competitive prices for all the category of solar installations. Industry experts, CPSUs, joint ventures, enterprise may consider to work towards development of projects on CSR, that is corporate social responsibility, for showcasing the advantages of adopting renewable energy on pilot basis. PSUs and industrial enterprise to set up their regional office in the islands for better understanding of the region's requirement for suggesting appropriate power generation models. Here, with this, I would like to conclude my session by saying that we work for 24/7 days with our aim for providing uninterrupted power supply and secured power supply in the whole Andaman and Nicobar Islands. Thank you.
Thank you so much, ma'am, for sharing expertise with us. Now I request Sri Manohar sir to present a memento to Miss Deepa Nair, ma'am. Please, sir. Now we have a short break for 20 minutes. please come back by 10:50. We have a tea break right now. Thank you. Attention please, there is a suggestion from a sir that we can have within a 20 minutes, if somebody wants to sit and have a discussion and question whatever he or she want to ask to Miss Madam Deepa Nair ma'am, anyone can. So others can move. If they want to have a tea break, they can move. If they want to have some discussion and questions, please stay. Thank you. Welcome back. After the tea break, we have to explore the vital topic on sustainable power for military bases, a crucial aspect for ensuring energy security and operational efficiency in our defense infrastructure. With great pleasure, let's welcome Mr. Brajen Kumar, IDSC, SC and Director Utility Andaman and Nicobar Commands to give insight on sustainable practices in military bases. Sir, please.
Good afternoon, respected dignitaries, the CII and the student and all the member faculties sitting here. So it's a great pleasure to be here, and I am thankful to CII and DeVrit University for inviting representative from the military to talk about the sustainable electric and water supply requirement in the military bases. In fact, I have just recently reported to this place. It's just 1 month back I was posted to the mainland and I was working for the Dehradun military base, and everything was sustainable there. So when we have reached here, we find we are totally dependent upon the state electricity board, which is Andaman electricity departments. And we have seen the presentations by the Andaman electricity department. They are also facing a lot of issues. And as we all know, Andaman has got very important place as far as the maritime security is concerned. And we can't compromise anything related to the security of the Andaman Nicobar place, because it hold a very, very important place as far as maritime security is concerned. For this, the requirement of electric and water supply is the prime. And we are striving hard, and largely we are banking on the state electricity department and state PWD department for the water supply requirements. But some of the measures which we have taken up to build in-house capability as well as some energy saving measures which I will be sharing in our slides. There are little bit concerns because of the security reasons. I will not be sharing some data related to our base, because it's very important place. So our presentations will be generic in nature only. We will be sharing some important information, and we will be seeking the guidance from all these industries people sitting here. And mostly we are seeking guidance from the consultants. The issues which we are facing, a lot of projects are in the pipeline, but it's not moving because of the peculiarity of the place like Andaman. But I'm sure the kind of now we have gathered today, and this is the first steps to move on, and we have got great potentials for the industries also. It's great potential to move on, and there are a lot of works, lot of projects are in the pipeline, and though the data I am not going to share it with all of you, but definitely when there will be need, we will be like to invite the consultant oblique the stakeholders. They can come there and then we can share all the important data. So with this I will move. My presentation will be sustainable energy for the ANI, basically for the military bases, but the military bases are not sustainable as on date on its own. Next. So we have been hearing about this sustainable energy. So what does this sustainable means? It's basically powering a green, we are looking for the green future, and the definition of the sustainable is meeting the need of the present requirement without compromising on the future capability or future ability. So basically there is a difference between renewable energy and the sustainable energy. So the aim of the sustainable energy is to get a clean and renewable energy. There are three pillars basically: It has got environmental, social and economic sustainability. So how much impact will have on the environment, whether it is going to affect the environmental issues. So we do basically environmental impact analysis, how much it has got effect on the social, and how much it will be, coming as far as the economic sustainability is concerned. And why we are doing all this? Because we have got these SDG goals. We must have heard, we all have heard about the SDG goals as by the UN missions. So we have to reach this sustainable development goals target by 2045. We have to meet the targets of the sustainable development goals. So we all are working towards meeting this goal. Coming to the electric load at glance, we are largely dependent on the Andaman electricity departments, and we have got our own DG sets. We have got captive DG sets. So whatever ma'am was showing that the load, the maximum loads, we are the consumers here, basically. Defense is a major consumer of the state electricity departments. But if you see the required load and the actual load, available load is only 16 megawatts. Actual load is 16 megawatt, but however, the load availability is only 12 megawatts. So we are getting only 12 megawatt as on date from the state electricity departments, though our requirement is 16 megawatt, and it is going to be much beyond this, I can say, because a lot of projects are in the pipeline, and in fact, some of the projects we have to shade because of the non-availability of the electricity. So that are the important projects, and we are, seeking and with guidance from the electricity departments. Once they will get the actual load, then we will able to move the projects. Whatever the shortfalls are there, we are going to meet the target through, we have got in-house DG sets. The defense has got the peculiar requirement, we have got peculiar load requirements. The load is varying. And why the load is varying? Because of the, especially the Hado area, its load is getting changed. Whenever there is a berthing of the ship takes place, load gets enhanced. So majority requirement is basically of the Hado area. We have got 6 megawatt requirement in Hado, 5 megawatt in the Miniway, like so. So the total requirement is 16 megawatts, and it's keep on changing. So sometimes the daytime requirement is 10 megawatt and the night requirement is 12 megawatts. So it's keep on varying. And mostly the loads are residential, and we have got operational assets, and we can't compromise, uninterrupted power supply is the prime requirements, we can't compromise. So we have got in-house our captive DG sets, and in fact we have got a standby DG set to a standby DG sets. That is the concept which we have gone. So we have got a state electricity department supply, then we have got a standby DG set, then we have got other DG sets. So you can understand the requirements for the defense as a peculiar, and the most of the loads which are mostly located remotely and isolated place, and seeing the peculiarity of the stations, some of the loads are unmanned. We have to be dependent on the sensors which have been connected with them. We got some area of the concerns. We have got frequent breakdown from the state electricity department because of their distribution network. They have got poor distribution network. I hope they will be improving it. Mostly the type of generation is captive DG sets. A lot of voltage fluctuations are taking place, and because of these voltage fluctuations, a lot of equipments are getting damaged. And you can imagine the cost of the equipments as far as the operational equipments are concerned. So if we can't compromise on these voltage fluctuations, so we have installed our HT voltage stabilizers in-house. The fuel efficiency of the captive DG sets is the major concern. The most of the DG sets are very old vintage, and some of the DG sets, because of the varying load requirements, it's either running underloaded or sometimes it becomes overloaded. So that efficiency of the fuel DG set, the DG sets gets compromised. The major challenges is manning and operation of our DG sets at the remote locations. Though all these DG sets are connected with the AMF, auto main failure, Then the most concept is most of the electric load requirements are, they are unmetered because of the operational requirements. They are not connected with the meter, so nobody is, taking care of the electric consumptions. Especially except the residential loads, all these operational loads are unmetered. So people are not taking care of that. So we are now trying to, I will tell you what are the steps are being taken, because we can't compromise on this. This already I have discussed. Then high tariff rates, what we are getting from the state electricity department, we have got high tariff rates. The another challenge is a fewer storage capability. Now whatever the DG set which we have, now where do you store these fuels for the DG sets? Then we have got non-availability of the skilled manpower is the major concerns. When one DG set gets off-road, getting it, repaired and it's a major task. So the guy has to come from the mainland, they have to get it repaired and all. Subsequently, the maintenance is also the big challenge. So that's why we have got standby DG sets to a standby DG sets. So one DG sets required at least 3 to 4 months to get it repaired at Andaman. Then most of the equipment has now got outdated, so we are working on it. So we have got this specific concept of declaring it VER. First it will get declared VER by the technical board, then it will be another work will get sanctioned and then subsequently will get replaced. But we can't compromise, so some of the DG sets we found that, getting it declared unserviceable within 10 to 12 years of the lifespan. Then we have got a spare part shortage. So these are the challenges which we are facing, and in fact, we have been, most of the things which we get, all these repairs and other things we get outsourced. So we basically hire contractor, we go for the bidding and all. And the L1 bidding concept, we all know how much problems which we are facing. The L1 bidders comes up, he quotes and then subsequently he get disappeared. So then again we have to go for the another L1 bidder, and hopefully he will not go get Vasak, and then we are hoping that he will get it repaired. So that kind of this government department has got this specific concept of the L1 bidding concepts, where this L1 bidder has becomes, he quotes it and then he fled away. So that is the biggest challenge. So with all these challenges and all, we are able to maintain, 24/7 electric supply to the bases. We can't compromise on this issue. So how do we meet the targets? So what are the options we have? So options we have got renewable energy source. So the 3 projects are in the pipeline, and in fact I can share with you, these projects were sanctioned long back in 2018, which is the solar power projects, which is there in Bridgeganj and in Nicobar. So total sanctioned project is 3.25 megawatt, and these projects were sanctioned way back in 2018, and it was tendered. The L1 bidder again, it fled away. Then we have gone for the L2 bid, another bidder, which is based on his risk and cost. And presently, he is also, not progressing the work as per the required pace of the target was given by the Prime Minister in 2020 only, to complete all the solar power projects on top priority. But however, we are lacking on that. It's again, we will be seeking some guidance from the industry people sitting here. Then the second project which is going to run is rooftop solar at different isolated place. In fact, 3 projects have been already installed, which is a capacity of 150 to 200 kilowatts. It's already installed. We are in agreement with NTPC, which is by the MOD. Under RESCO mode, they are going to install rooftop solar projects. Almost all the buildings have been identified, and the NTPC is going to install this, and they will be giving a power with the certain cost. So that project is already in the pipeline, and mostly, hopefully, that will be over by 2026, which will be, meeting the little bit targets will be able to achieve. We have gone for the feasibility study to harness wind energy. So in fact, I was hearing the renewable energy from the state electricity departments. They are not in the, they have not gone for any study on the wind energy at suitable locations, because wind energy in combination of the solar is the best combination for the hybrid energy, and that will give you the good outputs. So we have gone for the consultancy. Hopefully that consultant will come up with some solutions. Then we have gone for the consultancy on tapping tidal energy and a small hydroelectric plants at different locations. So hopefully that the reports will come up, and then we will go for the sanctioning of the projects. So again, here we will be seeking an opportunity for asking the industry guy to give us some solutions on this. Then we are going to try for the prototype bio diesel generators, and this LNG based power plant which we have heard that NTPC was in the agreement with the government of India. We're trying to install these projects now. The presentation is saying that project is not moving. I hope that project will see the day of the life, because this is the key of this Andaman, because that will give us the green energy. There are some issues with the renewable energy source, because it is not available round the clock. As you are aware, the climate is very whimsical, and every time the energy will not be available. It has got low efficiency, very high initial cost, and it is a space. It occupies a lot of space. In defense, we have got space constraints, and it has got adverse impact on the marine life also when we go for that tidal energy and all. The poor grid connectivity is another aspect, and this most important part is the roof. These solar projects, it has got adverse weather impact on the equipment. So I was reading one article where one 10 megawatt solar photovoltaic cells, they have gone in a study, and presently it is giving only 60 to 70% of the energy, which has been installed 5 years back. So that is a major challenge. The solar projects at Andaman Nicobar, how much it is going to give the effect. Like where we have designed this capability when our requirement is 1.2 megawatt. So we have gone for the 50% more. We have installed 50%. We are going to install 50% more photovoltaic cells. So I hope these kind of things will be taken care of. So the poor performance of the solar PV and its life is very important. So how they will meet the target, and in spite of all the challenges, so some of the energy saving measures which has been already dwelt upon by our Sankarao sir. So we are also in defense. We have already taken the measures. We have gone for the use of 5-star electrical appliances in all the future projects. So whatever the future projects are coming up, they all will have this 5-star electrical appliances like VLDC fans, LEDs, whatever the ACs, split ACs, they all will have this 5-star ratings. Then all these new projects will have this Griha norms. In fact, we are in talk with the IGVC. They are giving a consultancy on these Griha norms. All these projects, we have got 2% money is earmarked. So they will give us the consultancies how these buildings, and then we will go for the star rating of the buildings, which is a very important part. So hopefully, that the IGVC will respond on this. The third is very important, is installation of smart meters. So now we have got this concept of, earlier we have only concept of prepaid meters. Government of India has given a very clear guidelines as per the Ministry of Power guidelines. By 2025, all these places should we go for the smart prepaid meters. So earlier the concept of prepaid meter, now it has come to the smart prepaid meters. So in defense, already work has been sanctioned. Most of the places it is in progress. Like Dehradun, we have got all replaced by the smart prepaid meter. So hopefully in Andaman also, we have taken up the case, and all these, they will be metered. And not only residentials, we will be going for the OTM accommodations also. The operational assets also will be metered supply, so that we will be able to understand how much the energy is being consumed. So all HVAC equipment is being replaced by the energy efficient devices. So we all know, major consumptions of the electricity is HVAC equipments, heating, ventilation and air conditioning. So the most of the chillers which are coming nowadays, the ARI certified chillers, it has got this 0.56 kilowatt rating per turn. So that is the minimum requirements nowadays. And all these chillers which is being installed has got this rating approved from the ARI certified. This power factor is very important targets. So we are meeting our all power factors. All the installations have the power factor less than 0.95. Though here state electricity does not give us an incentive for this power factor, maintenance of this power factor, but we are maintaining this average power factor 0.95. We have gone for the replacement of all the VR transformers, which we have got all outdated transformers. Now the transformers are coming up with a level 2 and level 3. So all these transformers and HT switches which has gone outdated has been replaced. LEDization we have achieved 100% in our defense. The most important thing which we have gone for the energy audit for all these buildings, which has got more than 100 kVA load. So if it is more than 100 kVA loads, we have gone for the energy audits, and we have got the certified energy auditors in house. So they are doing this energy audit of the entire buildings, and they are coming up with this concept. And whatever the energy audits that recommendations are there, that is being implemented in phase manner. Balancing of load on DG and transformer is a major aspect. Like you find that fuel efficiency goes down when your load are unbalanced. And in transformer also, if load is not balanced, it will lead to poor power factors and all. VFD system for the pump. I was interacting with the Danfoss company. They are the pioneer of this. So variable frequency drive for the pumps. So it is mostly related to the HVAC equipments. So we have installed all these places the variable frequency drives. Proper billing I have already dwelt upon. Smart fuel monitoring for the DG set is a very innovative kind of thing. Recently has been done in the mini way as well as in Hardo, where we are measuring the fuel monitoring is done through a sensor has been installed. And then we can, we know how the DG sets the consumptions, everything is getting monitored. Maintenance of power factor has been already explained. The ECVC compliance buildings is very important. Energy conservation building codes. Nowadays, all these government building, they have to be complied with the ECVC code, energy compliance building. Here, earlier we used to have star rated appliances. Now we will have these buildings are star rated. And how this will be done, it is a EPI and a star rated buildings. It's called energy power index. So your buildings will be rated as per like if your building is consuming power. So this will be based on the per square meter how much power it is going to consume. So that is the rating is being achieved. So if your building EPI rating is less, EPI is less, so that building will be given a lead rating or a star rating. So most of the defense buildings now is going to have this ECVC compliance and the EPI and a star rating of the buildings which we are targeting. And that's later on that we will be taking up the case with the IGBC for getting this GRIA ratings. The AC cutoff temperature is set at 26 degrees Celsius as already dealt upon by our Shankar Rao sir. Solar and street lighting has been already installed. Solar pumps also has been installed at some of the places. The third bullet is very important. Most of our users are not aware about how energy usage and all. Though we have got very dignified users, but because it is not metered, so it is not metered. So they are not. This not they are not going to pay for it. So that's why this is very important. The awareness amongst all the users is very important, and that we have taken up the drive, and this drive is helping us. And in fact, we have achieved in last month only we have achieved at least 3 to 4 kilowatts at one location. Automation and SCADA in important buildings, though this is again it's a question mark on how much automation and SCADA is going to give you saving and how much initial cost. So that the rating is also going to be okay. The feasibility study of OTES, Ocean's Thermal Energy Conversions, that we are seeking an opportunity is has got very high potentials. In Lakshadweep, we have understood that the government of India is going to set up 100 kilowatt plants. So OTES also we are seeking an opportunity. If anybody has got this expertise, we will go for the consultancy. And it has got, that recent research has told that 10 megawatt capability in the Andaman Nicobar itself. So if you can tap this energy, this will be a major boost. EV vehicle is already, most of the government vehicles are going to have this EV. So what are the way ahead? Integrated and a stabilized grid, which is the need of the day, and the national grid connectivity through the undersea cabling arrangements. I have attended one G20 seminar where it has been already, I think it is the major requirement for this Andaman Nicobar Islands. Whatever we say, renewable energy and all, so this is the major requirement, that national grid connectivity, and it has been already, the Ministry of Power and everybody is in the consultations. One power, the grid connectivity from the mainland to the Singapore is going to come up, and it is going through our Andaman Nicobar Island only. So hopefully this national grid connectivity will, solve our entire problem. And this is the actual requirements for the energy need of the Andaman Nicobar. And this will be done by 2030. 2030, we will see the national grid connectivity. Use of floating solar photovoltaic cells, we can think about this. Danikari Dam is another aspect where we can go for the floating solar photovoltaic cells. Is very, very effective and very, very efficient. So we have installed in the CME Pune and it's functional there. LNG based power plant is another option. Solar wind hybrid system, though we have got less time, I will just rush through. Installation of large scale OTS power plants, this we are seeking consultancy for that same. Use of biomass to generate renewable system electricity and the cooling. These are all the conceptual things. Ultimately it will be seeing the day of light. Then this battery storage is the major concern. Whatever the solar power which you are going to receive, it should have this better storage capability. So this is the latest technology which has come, iron chromium redox flow battery technology for the storage. Here also we are going for the consultancy. Hopefully that will also see the day of the light. That's all I finished. And I will request, so I will be requesting all these consultants present here and the industry here. Thank you. Thank you very much.
Thank you, sir. Now I request Shri Arun Srivastav sir to present a memento to Mr. Brajen Kumar sir. Please, sir. Actually, the people are waiting through online. They have some commitments. As we are aware, our island are currently facing some significant challenges in electrical supply due to limited infrastructure reliability issues and integration difficulty with solar power plant. To address these concerns and explore a strategic approach for enhancing energy performance, reduce cost and achieving sustainable energy solutions, let's welcome Ms. Nisha, Principal Counselor from Shorabji Godrej Green Business Center, to shed some light on roadmap for energy efficiency goal for Andaman Nicobar Islands in virtual mode. So please connect.
Good morning, everyone. Am I audible?
Yes, ma'am, you are audible.
Excellent. And is my screen visible?
Yes, ma'am. Now it is visible. Please start, ma'am.
And can you just confirm that it's moving as well? I think it is. Yes?
Yes,
okay.
ma'am.
All right, great.
Yes, ma'am.
Okay. Thank you. Good morning, or maybe good afternoon. We are really close to noon. Thank you for having CII here. As a quick introduction, my name is Nisha, and I am from the CII, so Shorabji Godrej Green Business Center in Hyderabad. I'll talk a little bit about what we do here towards the end, but I just quickly wanted to talk about something on energy efficiency for the Andaman and Nicobar Islands. So just quickly as a background, perhaps most of you are aware of what's happening in the world regarding climate change, global warming and all of these things. And you would probably have heard of the Paris Agreement on climate change, which was signed in 2016 by a majority of countries from around the world. Essentially, this was the first time that the world as a whole came together to commit to reducing emissions in order to limit the average global temperature increase. So scientists have clearly said that if we are not able to limit global average temperature increase to less than 2 degrees, the world is going to go into uncontrolled warming. So it will be a feedback loop which will make the globe warmer and warmer, which in turn will create a lot of issues for humans to survive, because a lot of changes in the weather. There's going to be a lot of torrential rain, a lot of droughts, ice caps melting, the sea levels going up. A lot of issues are anticipated if temperature increase continues. And therefore, in 2016, most of the countries in the world came together to commit to limiting average temperature increase around the world. Now, India, of course, also committed at that time. But between 2016 and 2020, India realized that, its original commitments, it was already able to meet them. I'll not go into the details of what those original commitments were, but because India realized that they were already able to meet those original commitments, the Honorable Prime Minister in 2021 at Glasgow announced, tighter goals for India, stricter goals for India. And I'm sure that many of you have heard of these. These are called the Panchamrit goals. However, I'll still just quickly go through them because we've discussed a lot about renewable energy, energy efficiency, etc. So the first goal was that India's non-fossil energy capacity would reach 500 gigawatts by 2030. The second was that India will meet 50% of its energy requirements through renewable energy by 2030 again. India will also reduce its projected carbon emissions by 1 billion tons from now by 2030. And the country will reduce the carbon intensity of its economy by 45%. And finally, the big deal was the announcement of net zero emissions from the country as a whole by 2070. Now, of course, this is a really big deal because India is a developing country and therefore, uses a lot of energy for this development. Perhaps many of you would already be aware that typically the energy use curve will follow the GDP curve of the country. This is because typically to increase GDP in developing countries, at least there has to be an increase in the usage of energy. Now, while 2070 may seem like really far away, 40 plus years away, if we don't start strategizing and planning and acting for the 2070 goals now, it will not be possible to actually achieve this target. Therefore, what has been done is that the Ministry of Power of India has realized that this is required and therefore decided to act on it. Now, one of the key ways to achieve net zero is to improve the efficiency of use of energy, be that fossil fuel, be that electricity, right? And to be very frank, India is going to be dependent on coal for a few years to come. So it is not like we can remove coal or other fossil fuels like petrol and diesel out of the equation just like that. It is going to take some time. Therefore, the Ministry of Power embarked on a project to see how it can support all the Indian states to improve their energy efficiency as a direct path towards reducing overall energy consumption. And like I said, reduction in energy consumption would also reduce emissions. Thus, it will also be a path towards net zero emissions. Now, as part of this activity, the Ministry of Power requested CII to support the development of energy efficiency action plans for 12 states in the country. And Andaman and Nicobar Islands was one of the states / UTs that we worked with. And what I'm going to talk about over the next, say, 5 to 7 minutes is essentially something that, we recently presented to some of the key stakeholders in Andaman and it has been finalized. So I'll just quickly move into what we actually did. So initially we had to identify which are the focus sectors that we need to consider for energy in Andaman. And this was based upon a few factors. We looked at what is the energy consumption from different sectors, what are the emissions from these sectors as a result of that energy consumption. We looked at what is the gross value add to the state or the UT's overall GDP. We also took a lot of stakeholder input. So we discussed with a variety of government departments, all of whom would be involved. We also discussed with some industry and also some commercial buildings in Andaman and Nicobar. And of course, we had to merge all of this with the government's vision for the state, for the union territory as well. So with all of these, we identified 5 focus sectors, but I'm going to talk about the 3 most important here. And those are transport, buildings, and fisheries. So quickly, I would just highlight what were the things that, what were the elements that we considered. Transport in Andaman is one of the major consumers of fossil fuel. Lot of cars, lot of bikes, lot of two-wheelers, lot of three-wheelers, all of which consume a lot of petrol and diesel. So one of the things that we have recommended is to see how quickly the existing fleet of petrol and diesel vehicles can be converted to electric vehicles. Of course, some of the previous speakers were also talking about electric vehicles. So how quickly can we convert into electric vehicles? Now, some of you may have a question about anyway we are generating electricity, a majority of the electricity generated in Andaman is through diesel, then how does converting into electricity or electric vehicles help us? Well, the thing to remember is the first point of conversion or removing fossil fuels out of the equation is to electrify. Because the moment you electrify, then you have the option of using renewable energy. So unless you electrify, you cannot use renewable energy. So the first point is to electrify. And of course, this is a process. It takes some time, right? So unless we start now, by the time we build up renewable energy capacity, we will not have electric vehicles or electric fleets. And therefore, it is important to start right now. Of course, converting to electric fleets will also require a lot of other ecosystem changes. So we will, in addition to approving the purchase of electric vehicles, we will also need to look at things like how do we fix up the charging infrastructure, because that is going to be very key. We need to see how people can be made aware about electric vehicles, because there are a lot of concerns about electric vehicles currently. The government can also see if they need to bring in some licensing restrictions for existing fossil fuel petrol and diesel vehicles in order to encourage that shift to electric vehicles and so on and so forth. So there, of course, it's not a simple thing. There are a lot of issues to be considered, but electrifying will be one of the first steps. Electrifying of vehicles will be one of the first steps towards utilizing renewable energy for that, and thereby reducing dependence on fossil fuel as well as eliminating fossil fuels from the equation, thereby eliminating that amount of carbon emissions. The second thing that we have suggested is to encourage adequate public transport. Due to lack of time, I'm not presenting the numbers that we have, but what we see is that a majority of the vehicles on the road, if you draw a graph, you will only see that there are two-wheelers, three-wheelers, and four-wheelers, all largely private owned, and we see very few buses. Of course, a couple of months ago when I was in Andaman, we had a discussion that the government is procuring 100 plus electric buses, and that is the right step in the right direction. However, it is also important to ensure that adequate public transport is there so that people can reduce dependence on their individual vehicles, right? Public transport is one of the first things that we talk about when talking about reducing emissions. So, of course, the government has to see how it can provide adequate public transport. Again, while we understand that electric vehicles could be a long-term strategy, it is also possible to develop short-term strategies where you offer more fuel-efficient vehicles which can provide public transportation. The third thing we looked at was, while road transport is one part of it, Andaman Islands being an island has a lot of maritime transport requirements. So ships and boats that go between the islands and the mainland, they also consume a lot of fuel. One of the things that is getting done internationally at ports is that ships which are docking, be they passenger ships or freight and cargo ships, they may be provided a power supply from the shore rather than burning diesel, which is a lot more precious and which results in a lot more emissions directly from the ship. So this is something called onshore power supply, and this is something that's used internationally, and you will also find this being used in a lot of airports in India, so that airlines don't use aviation fuel. A similar thing can be done with ports as well, and we would encourage the Andaman government to consider this. This will also result in significant emissions from the maritime sector. The second thing that we also wanted to talk about when we talk about transport and maritime, when you consider cargo ships, etc., there is a lot of time spent and a lot of energy spent loading and unloading cargo from ships. So how can all of the equipment that is used in ports for loading, unloading and other activities like cleaning, etc., be made energy efficient? Because a majority of the forklifts, a majority of the cranes, etc., currently run on diesel. So one, using more efficient, equipment, and second, transitioning all of these equipment to electric as well. So these days, many of these equipment, for example, cranes and others, are available in electric form as well. So we would encourage the government to consider these activities. The next thing that I want to move on is to buildings. We just heard that the residential buildings are a large part of contribute significantly to energy consumption. So do commercial buildings. So one of the suggestions we have is to notify something called Eco Niva Samhita, which is an initiative by the Ministry of Power, the Bureau of Energy Efficiency, as well as ECBC, which is the Energy Conservation Building Code. So ENS and Eco Niva Samhita is for residential buildings, while ECBC, Energy Conservation Building Code, is for commercial buildings. So the UT needs to necessarily notify this. What this will do is bring in a certain level of standardization in terms of the structure, the equipment, etc., that go into the building, which in turn will improve energy efficiency and therefore reduce consumption of power. The next thing that we had suggested on buildings is to, of course, encourage more and more people to use the highest level of star labeling that is available in the country, which is essentially 5-star. Earlier in the day, the professor mentioned that all the equipment that they're purchasing is 5-star. It would be good if the government can in some way mandate that all the government buildings will only purchase 5-star, and then encourage other consumers like commercial and residential consumers to buy 5-star, but perhaps providing some incentives, etc. Of course, we have discussed in detail about how all this can be done with the government stakeholders earlier, so I'm not going into a lot of detail here, but these are some of the things that we have recommended. The last action plan that we have suggested for buildings is to promote green building rating systems. Earlier, we have had discussions on IGBC, etc. So IGBC is a green building rating system, and I'm very happy to say that I work with the team here in Hyderabad from IGBC, which develops all of these rating systems and which encourages the buildings in the country, the entire country, to go green through these green building rating systems. Green building rating systems are good because they not only reduce energy consumption, but they also reduce water consumption, they reduce generation of waste, they improve the indoor air quality, which in turn means better health for people, better productivity, and so on and so forth. So there are a lot of benefits to green buildings that go beyond energy and energy efficiency. The next thing is that fisheries is of course a major sector in Andaman, being island surrounded by the sea. Fisheries is a major sector, and we thought that the fisheries sector could also become more energy efficient in a few ways. One would be in terms of bringing in efficiencies into the cooling value chain of the fishery. So using more efficient refrigerants, using better processes to cool fish and other marine products initially. So in addition to reducing energy consumption, all these will also improve the quality of the final produce, which in turn means greater value add and greater revenues for both the state as well as the fishermen. So there are multiple co-benefits to getting the fisheries sector, particularly the cooling chain, etc., to become more energy efficient. I would like to note here that everything that we as CII have suggested to the government, these will definitely create a lot of impacts, but we also appreciate that these are not things that you just snap your fingers and they will be done in 1 month or so. All of these take significant amount of planning, significant amount of investments, but it is also to be noted that in addition to the environmental positive benefits, a lot of these activities will also create new jobs. So it makes in a way business sense for everybody involved to go green, to become more energy efficient. I just have a quick summary slide, some of the numbers. I don't want to go into the details of the emission reduction and energy consumption reduction. We have calculated this, we have analyzed this with multiple scenarios based on some assumptions and based on some actual numbers we have received from the government departments. But what I wanted to indicate here is that there is also significant investment potential in undertaking all these activities, and like I mentioned earlier, investment will automatically generate more jobs, will create a better economic situation for the union territory as a whole. So this is sort of the recommendations that we have made. But before I close, I would just take a moment to just talk about what we do here at the Green Business Center. Essentially, we work across a whole spectrum of areas and activities through which we try to impact climate change, or we try to reduce the impacts of climate change in India. We work with industry, we work with government, we work with a whole lot of other stakeholders around the country. So we house the Indian Green Building Council, which currently has almost 12 billion square feet. It's a huge number that I'm talking about, 12 billion square feet of registered green building space in India. This is the second largest footprint in the world, actually, after the United States. We then have something called the Green Co-Rating System, through which we work with industries around the country to enable them to reduce their overall environmental impact. So this talks about everything from energy and carbon emissions to water management, waste management, understanding impacts of the products on the environment, managing end of life of products, and so on and so forth. It's a very holistic framework that is used to encourage companies. We have an eco label called the Green Pro Eco Label, which gives people the choice to buy green products. We have an energy team which works extensively with Indian industry to help them improve energy efficiency and to help them reduce their carbon emissions. And finally, we also work with a variety of clean technology entrepreneurs to help them become bigger and to help industry access some innovative technologies. So with this, I close. This is a photograph of the building that I'm sitting in right now. It is actually India's first green building, and it is also a net zero energy building. Thank you very much for your time. My email ID is here. In case you want to reach out to me later, I'm happy to get back. Thank you very much for your time.
Thank you so much, ma'am. Your presentation was truly enlightening. Thank you.
As we continue to explore sustainable energy solution, hydrogen has emerged as a promising contender for a cleaner and greener future. It's my great pleasure to welcome our esteemed speaker, Mr. Siddharth Mayur, Chief Executive Officer H2E, a leading company at the forefront of hydrogen technology and innovation. Mr. Mayur will also share his insight virtually. Please connect.
Good morning, everyone, respected guests and dignitaries. First of all, I want to thank CII and the management in Andaman Nicobar for providing us with this platform and opportunity to discuss some very important subjects connected to sustainability. I mean, I would not really get into green or blue or any color, but sustainability, which I think is the most important aspect of work on places like the island of Andaman and Nicobar. We represent the hydrogen ecosystem, and I've been hearing the earlier speakers, and I was very encouraged with the problem statements that have been presented, especially by Vijendra Kumarji on the defense side, what issues that they face. And I think this exactly is a space where hydrogen can do a major difference on the island of Andaman. The solutions that hydrogen can provide, solutions that the distributed generation or microgrids using hydrogen as an ecosystem and fuel cells can really make a huge difference. And I'm just going to speak a little bit about what we can do, and we've already had some interactions with the defense team in Andaman, and we've been working on some solutions. But this is, I think, a very exciting space. This is a very interesting space, and one of the areas where there can be an immediate impact. So, we always term the implementation of the National Green Hydrogen Mission or the hydrogen ecosystem into different phases. And the first phase or the lowest hanging fruits are island states like these. And that's where even we can have a cost parity or a cost advantage. Is my screen visible here?
Yes, sir.
Thank you. So I represent a company called H2E Power. We are in the green hydrogen fuel cell and the net zero ecosystem as a business. We are a 14-year-old company, completely developed and made in India, like I call it. What I'm going to talk today is more about the electrolyzer and the fuel cell technologies and how hydrogen is playing a role in, of course, the global scale on energy efficiency and or carbon emission reduction, and also make us more and more independent. So for me, the bigger story is energy independence and energy security. The green comes as a very potent byproduct of whatever we are doing. But today for India, and I always say this across the world, that for us the bread and butter is the key issue. Green definitely is important, but it's not the primary issue for us. We have to make sure that we get 24/7 energy, and when I say energy, it is not just electricity, it is also the fuels that we use. So if you're looking at how hydrogen works or what hydrogen can do, or the industries where we look at hydrogen being utilized either directly or indirectly. So production of hydrogen today, if you're talking about green hydrogen, we look at two different ways to produce that. One is the biogenic route, which I will not be talking a lot today, but I will speak about the route from the electrolyzer, which is through splitting of water. And why I'm focusing more on this is because taking the Andaman Island in perspective, you have a lot of water body. I mean, it is surrounded by water all over. Desalination of water is very much possible. And if you're doing hydrogen production by water splitting, the space required is limited. You can always use the solar infrastructure, like we talk about energy storage. Hydrogen can be a very potent energy storage for long-term energy production, whether it is electricity or also whether it is alternate fuels that we produce. So electrolyzer as a technology is very well developed now. We are talking about commercial implementation of these. The government of India has already formulated the National Green Hydrogen Mission, under which the first phase is already being sanctioned, and PLIs have been issued for hydrogen production, for electrolyzer production. There are PLIs that are coming in for ammonia production as well. So there is a lot of activity happening on the electrolyzer space as we speak, and these technologies are becoming more and more inexpensive. And the numbers that I heard today during the earlier speakers' discussions, I believe even at a high capex that electrolyzers are today, we still will be able to provide the energy end to end to islands like the Andaman at a price parity of what they are spending today, or maybe even lesser. You'll be surprised to know that we could even be cheaper than diesel at the price that they're getting it today. So we can, cater to different industries. Mobility is one, and the shipping industry is something that can greatly benefit the Andaman Islands, where we are talking about hydrogen-based ships. There have been catamarans and also ferries that the Kerala government has already demonstrated. These are built by Indian companies. They are completely made in India. The hydrogen infrastructure is what is getting into place. So the key applications again for hydrogen would be power generation and heat generation. So when I say heat, we generally use the fuel cells. If you are using hydrogen in a stationary purpose for electricity generation, then these are combined heat power systems. And when I say heat and power, for every kilowatt hour of power that it produces, we produce 1 kilowatt hour thermal equivalent of heat. And that heat is a very good quality heat. We bring heat at about 250, 300 degrees centigrade, which can have multiple uses. One of the use, of course, can be for the cooking and the toilet applications, bathing and cooking. But the other application is to convert this heat into cold air, so through absorption chilling, and that can take care of all the air conditioning needs. And this again is a 24/7 process. So as long as the sun is shining, as long as there is water available, we'll be able to produce this. And that can greatly not only reduce the pollution on the island, but will also give a 24/7 feel to everything. So whenever we are talking about a solution on hydrogen, we always talk about 24/7, clean, green, reliable and affordable. So powering buildings, powering smaller places. Now again, the fuel cell technology is scalable, right from a 1 kilowatt system to a multi-megawatt system. The efficiencies don't vary quite a lot. Of course, the capex varies because on 1 kilowatt, the capex is a little higher. On a megawatt, it is lower. And these are best suited for distributed generation. They work on efficiencies of close to 60-65% efficiencies. So they are one of the most efficient devices. If you take the combined heat power efficiency, we are talking about 92 to 93% efficiencies. The second use of hydrogen is to produce industry feedstocks. So if you are looking at producing ammonia, for example, and if the Nicobar Island is what the government has been talking about, developing this whole bunkering facility or a large port facility to counter the Singapore port, there to produce ammonia for refueling of ships can be a very major business opportunity that the hydrogen ecosystem can provide. And then also synthesis gas. So if you combine hydrogen with carbon, which is there in the atmosphere, you capture carbon, you'll be able to produce synthesis gas from which you can produce multiple different hydrocarbons. And this, especially for the defense forces, to produce methanol on site using these green technologies can be a very effective use of hydrogen. So if we are able to do the typical Indian jugaad, and if we are able to come up with some interesting solutions which the world has not seen, because the world does not have the kind of challenges or opportunities that India possesses or India provides for, we'll be able to really make good use of these technologies. The last area that I have been very focused and looking at is the transportation, whether it is internal transportation on the island, you use the forklifts or you have three-wheelers. We just heard that there are a lot of EV buses that are coming into play. To provide charging infrastructure for these EV buses is also where hydrogen can be used to produce distributed scale AC or DC electricity to charge these vehicles, or even provide hydrogen directly if you have hydrogen buses. We already have close to 20-25 hydrogen buses in India which are running in different places, right from Assam to Leh Ladakh, Delhi, Gujarat. So this is something that definitely is worth a try for the Andaman Islands. Three-wheelers on hydrogen, buses on hydrogen, and also ships on hydrogen. So refilling of the ships can also happen. This is a little snapshot about what the National Green Hydrogen Roadmap is. So we are talking about a huge opportunity that is coming into play with an investment of close to 8 lakh crore rupees, which is expected by 2030 getting into the country, and the benefits of which are going to be on the mainland as well as on the islands that are part of the Indian Union. And the government has sanctioned already 19,700 odd crores, out of which, like I said earlier, some of these projects are already on stream and they would be live in the next couple of years. My company has been one of the PLI winners on the electrolyzer manufacturing. So we are all working towards, making this whole concept of hydrogen Atmanirbhar, make it in India and provide at a better price to customers in India and across the world. The targets that we have already spoken about, and these are, I think, very important dates which all of us should memorize and remember. So 2030 is when we as a country would announce that we have arrived on the hydrogen or the net zero ecosystem. And that includes all the areas that, I have spoken about. There is a lot of work happening on that. By 2047, we are talking energy independence, means that the $200 billion that India spends today to import energy will probably become zero, and we will spend all of that money within the country. So, that's the level of opportunity that we are looking at and the level of solutions that we can implement within the country. And 2070 is net zero. 2070 looks very far, but it's still a very steep target to reach net zero as a country by 2070. If we are able to achieve that, I think that will be a big achievement as far as the world is concerned. I think I've covered this, but I will still, talk about the focus areas on hydrogen. The refining sector, the fertilizer industry, of course, remains the key consumers of hydrogen, and they constitute about 4.5 million tons of hydrogen utilization. But by 2030, India is looking at doubling up the hydrogen utilization from 6 million tons to about 11 or 12 million tons. And the incremental increase is going to come through all of these innovative ways of using hydrogen to bring independence or to take care of the energy issues that are faced by different areas, different states, different islands within the country. So energy storage is an important part of where hydrogen is to be used. Blending of hydrogen with natural gas. So if you have a biogas plant that also you set up on the island, we can always blend hydrogen with that biogas, which will make sure that the end product has a higher calorific value. So for a lesser amount of gas, we'll be able to do much more work. So, the kilocalorific value of hydrogen is the highest amongst all the molecules on the periodic table. So it is number one on the periodic table. Aviation and shipping. So shipping is something that is of importance to the island of Andaman. And production of e-fuels, like I touched upon methanol, I touched upon ammonia. These are important areas, and with limited space, without causing any damage to the environment, without cutting any trees there, without harming the flora and fauna, these areas can be explored on the Andaman Islands. There could be specific zones that could be declared where, we could produce these. And because you have a sea route available, it's very easy to ship it. Even if you have to ship it to mainland, those business opportunities exist. A little brief on the microgrid that I touched upon, and I think the earlier speaker, Deepaji, also spoke about the rooftop solutions or the rooftop potential that we are exploring as a country in the Andaman Islands, close to 29 megawatt of solar or with 20 megawatt of battery energy storage. If we can look at microgrids, wherever we have a solar rooftop, if we can use the incremental solar power available with small scale electrolyzers, produce hydrogen and store them, this will help us ensure that with a minimal investment, we will be able to get a 24-hour solution, and a solution which is sustainable. So, this is till the time the sun is shining, till the time you have water available, we'll be able to produce electricity, fuel, and also heat, which again has multiple uses. And these microgrids we have already demonstrated in India at various locations, whether it is a small home or it is an office or even a microgrid at a power station at NTPC, for example. These microgrids are very prevalent in Europe. My company has been very proud on the installations we've done here. About 600 of those installed in Germany and working for the last 10 to 11 years, working with very high efficiencies. So this again is a concept that we are promoting in India is for the charging infrastructure for electric vehicles. See, today we are all using the grid to power our electric vehicles, which is a good thing. But if you really look at the carbon emission side, we are emitting more carbon doing this because it always is well to tank and tank to wheel. So tank to wheel we are green, but the well to tank is coming out of the coal grid or the gas grid. And here we are talking about a distributed grid where you have a small 20-feet container which has a solar fuel cell battery hybrid system, and you can place it anywhere and it uses biogas as an input. So it can charge electric vehicles and provide for a greener infrastructure, which again I believe can be a very potent solution which is worth a try on the Andaman Islands. The last but not the least is the transportation segment, and this is something that, like I said, has been demonstrated in India and has a large potential. We are also exploring potential right from the Brahmaputra basin up to the inland water transportations for passengers as well as for cargo. And because the Andaman Island, the only mode of transport to and fro the island is through water, pilots on the ships or catamarans using hydrogen can be very effective. It would not only save on the carbon, but would make it much more efficient. And if you're talking a comparison with an electric boat and a hydrogen boat, the efficiencies you can get on a hydrogen are much more higher. And we always talk about a hybrid. We never say that it is pure hydrogen. We take a battery and a hydrogen hybrid, and that's how it works. And the refilling time, of course, is very, very low. So this I think is a very important solution for the Andaman Island. And to end my presentation, I just want to put some thoughts to the minds of people here in the audience, people who are decision makers and people who also can help us implement these projects on ground. We really should look at pilots where we go with the microgrid using green hydrogen with the current or the upcoming rooftop solar infrastructure. And I believe this can really make a big difference between becoming energy independent and leaving that small gap where you still need external energy. To explore the CHP systems on the microgrid and where we can capture the heat and actually start also producing cold air. These are again mature technologies. When I'm talking about absorption chilling, it is a mature technology for 50 odd years, and this can be easily installed, that can be very easily demonstrated there. We should look at setting up green hydrogen and green fuel pilot plants for transportation, especially for waterways, but also for inland transport. So if we can look at a couple of buses running on hydrogen, a couple of three-wheelers or these golf cart kind of minis running on hydrogen, that could be a good project to look for. Again, the emission from the hydrogen vehicles is just water, so it really is not a concern to the environment. We can always collect that water and recirculate that water to produce further hydrogen. So it can always be looked at from that angle. Clean cooking is another area where it's not a very talked about area, but people always, whoever is living anywhere needs to eat food, and if we can look at pilots on clean cooking, there is a lot of work happening on solar-based cooking devices. There is also a product that we have developed within my company, where we are using a battery hybrid. We use a very interesting battery technology which is made out of salt. It is a sodium nickel chloride battery, which is also very useful for your battery energy storage systems. So using this battery and solar, we've developed this cooking device which can provide for clean cooking on a 24/7 basis, either for a small home or a larger setup. And I think this can be a big difference in terms of energy efficiencies that we are talking, also in terms of greening the entire cooking segment. Coming to the military base, there is a lot of work and there is a lot of potential from hydrogen. I mean, I can have a separate presentation only on that. There's so much of things that we could do. And these are again technologies which are mature technologies. I'm not talking about something which is a Alice in Wonderland kind of thing that, these are ideas that we can develop in the next 10 years. These are projects which we can implement immediately on a pilot basis. So whether it is production of methanol, whether it is replacement of the DG sets that Brijendraji talked about and the difficulties that they're facing with managing 24/7 electricity, I think, sir, hydrogen is the solution for you. We can do pilots with H2 gen sets. We can do pilots with hybrid of making microgrids there. We could produce different kind of fuels. We could run your vehicles. So that is a very large potential. And in terms of cost, I can assure you that even today, with a high capex on the hydrogen technologies, we will be at par or cheaper than the DG sets you are using or the other technologies you are using for generating and utilizing power there. So thank you very much. And if there is any questions, I'd be happy to take those. Sorry, I could not attend this meeting offline. I've been traveling out of the country. But would be very happy to come visit the island and see what more we could contribute towards developing a net zero ecosystem there. Thank you very much.
So thank you so much for your invaluable input and for being a part of our workshop. Thank you so much. If anyone
Thank
is
you.
having any question, we can take one or two questions if you have. Or else we can start with the next presentation. So now we have Mr. PM Nanda, Executive Vice President, Greenco. He will also share his insight online and he will talk about energy storage systems. So we welcome you, sir. PM Nanda.
Hello. Good afternoon, everybody. Am I audible?
Yes, sir. Good afternoon, sir.
Yeah, I'll try to share my screen now.
Yes, sir. Your screen is visible right now.
Yeah. Good afternoon, everybody. Just share brief insight on the storage technologies. I've been listening to a lot of presentations. I think most of the things on storage technology basically are being discussed in this. My thought process is with reference to the needs of Andaman and Nicobar, because what I heard from the presentation is that the requirement of power is around 29 megawatt there, and a lot of voltage fluctuations and other issues are being faced by the defense people, defense establishments, and because of which they are incurring heavy loss on the maintenance of equipment, etc. So I think what I see is that looking at the topography of Andaman Nicobar, availability of area for the solar or the suitability for the wind projects, I think there are a lot of discussion that some studies are being taken up by the defense and by the renewable agency for wind power also. I think that's going to be very feasible there in the Andaman Nicobar area, wind definitely. Though the PLFs might be slightly lower as compared to the other areas, but definitely the wind is area where the suitability in the Andaman is not a question mark, I personally feel. So looking at those availabilities, I think the solution for Andaman Nicobar lies in the storage only. They have to create energy storage in the island, and that is where the solution lies for all future needs and all times to come. Once energy storage is there, I think all hydrogen and other molecule ideas or other expansion of establishments, etc., will come automatically. Well, just brief about working in Greenco. We are a renewable energy company, and we have been doing a lot of work since last 20 years. We started with the clean energy development, and now we are building a large storage energy network, and then going towards the decarbonization that is providing molecules, hydrogen, methanol, etc. So that's where we are working. We are planning to have 20 to 25% of the storage share of the energy market of India and 40% share of the green molecule market by 2030. This is where we are working for. And we are doing a lot of projects on pump storage projects. And presently we are working on 100 gigawatt hour initiative for the country. We are working in 7 states. And we are developing projects. By 2029, we are planning to developing 100 gigawatt hours of storage. So this is what our brief background is. And if you look at the storage global status, you will find that almost 90% is being done by the pump storage projects. And around 10% is done by the other storage technologies, wherein around 7 to 8% is for the batteries. So there are primarily two kinds of storages which are primarily being done all across the world. Batteries are developing fast, so we'll see this change in percentages coming up very fast. Pump storage going down a little bit, and battery storage might be coming up a little bit more. Both these technologies are very useful for the storage, and both of they have their own share of area where you need those storages. If we look at batteries are required for the smaller duration of storages, 2 to 4 hours of storages. But if you are looking for longer storages, 6 to 8 hours, then no other solution than the pump storage project is available as on date. And that's the most viable, most economical solution and most environment friendly solution available. Just brief on the technology which we have as on date. We have a lot of technologies, mechanical, electrochemical, thermal, electrical, chemical, which are there presently in contention, and a lot of R&D is going on each technology to make them workable, make them economical, make them viable. But more or less two technologies with pump storage and electromechanical side, the batteries, various combinations of batteries, lithium ion, sodium nickel, vanadium redox, etc. are going on in development. And very soon we'll see the large scale development of these and making it a viable option also. Maybe we are another 2-3 years down the line, we'll be seeing that more of the batteries coming up in a big way. But when we look at the suitability of the technology, we have 3-4 parameters where we look for the suitability of a storage technology. One is discharge time. How much hours you can store the power. And second is the capacity which can be catered to that requirement. And if you see on the far right top pump storage. So that is a storage which you can do in big scale, in gigawatt scale, and you can do the storage for days altogether. And when you move down towards the left side, you see that batteries are again, which are medium scale also, which can store for longer hours, not the days. So they are also developing very fast, and they are the another source of energy storage, which is a very viable and useful source of energy. And then the another parameter which is important is round trip efficiency, because when we do the storage, we lose some power. If we store 100 units, we get back around 80 to 85 units only. So it's a basically net loss of energy, but the economics come with the differential rate which we use the power from the various time of the day tariff. So if you look at the round trip efficiency also, you see batteries and pump storage power almost at the par, same level of efficiencies. So they are equally efficient, both the technologies. And there is another part when we come to the technology readiness and the manufacturing readiness of these technologies. We have scales from 1 to 9 for the technology readiness and 1 to 10 for the manufacturing readiness. And when we analyze all these technology, we find that the pump storage project as of now, from the technological readiness and manufacturing readiness, is the technology which is available and which is in use for last 60-70 years.
Sorry to interrupt. Kindly put it on a presentation mode.
Okay.
Thank you, sir.
Yeah, I think it's clear. So lithium ion batteries also, we see that they are also technologically fully developed now. Manufacturing scale on the commercial level is going on very fast, and we'll be achieving
Sir,
that.
it's still not on presentation, sir.
It's not visible?
It's visible, but it's not on presentation mode.
It is on presentation mode. Let me see how it is going on.
Yeah, kindly make it a slideshow, sir.
I've done that only. From my side, it is being shown like that only. Is it now?
No, sir, not yet.
To me, it is showing as a slideshow mode only. I don't know how it is happening. To me, it is visible as slideshow only. Now I have suppressed it, but earlier it was showing as slideshow only.
Is sharing wrong? Yeah.
Yes, sir. Now? It's sharing now?
Yes, but
is it not visible clearly?
Actually, you are sharing a wrong screen, sir. Just stop sharing and share it again, sir.
Okay, stop sharing. Is it visible now?
Yes, but we are on the same screen, sir. It's
It's not coming on full screen.
Sir, please press F5 on your keyboard, sir. F5.
I don't know why it is not coming. Your screen sharing, it's showing here. No, I don't know what is happening. No. Not visible? What is it?
Yeah,
What is the visible of,
yeah,
what is visible on the screen?
it is visible, sir. Slides are visible, but not on the presentation. So slides are are smaller. So it's not readable actually.
There's some problem with the sharing. Run full screen.
No problem, sir.
Getting
Sir, please carry on, sir. Please continue.
Okay.
Thank you, sir.
So we see that this is technologically and manufacturing level, both technologies are fully mature. Now we come to the pump storage project. Pump storage projects are basically many types of projects. Some are river based, some are off river based. Off river based projects are quite suitable. You can see in a picture that we create two artificial reservoirs. When sun is shining, energy is available or wind is available, we pump the water from the lower reservoir to upper reservoir. And when we need energy, we draw the water from upper reservoir to lower and generate energy. I was looking at the topographical side of the Andaman Nicobar. I think there's a lot of potential available in the southern Andaman and the middle Andaman, where the energy storage projects of a suitable capacity can be developed. Since the energy needs of Andaman are quite small, I think the projects with 20 to 30 megawatt of capacity from 8 to 10 hours of storage can be comfortably built in that area, which will be very cost effective. I was hearing the presentation that they have a DG system backup and then again second state backup for the DG backup also. I think that's too costly a solution to be available at the moment, but that's indeed needed because of the requirements. I think these projects which I am talking about in Andaman will be a smaller capacity, less than 25 megawatt, for which the clearance process is very, very easy. You don't need environment clearance for these projects. You don't need the concurrence for these projects, technical concurrence, and these projects will be very fast developed. In 2.5 years, this project can be developed and put in place. I think there's an urgent need that the local government system looks it in a broader way and start developing these projects, because this will be a long-term solution for years to come, because these projects have longer life for 40 to 60 years. So I think that's where the need is coming for these storage projects, and they are equally viable solution for this. This is just different type of storage projects which we have. When we have two separate reservoirs off stream, we new reservoirs we construct, they are not on the stream, we call it off stream. When you work on the existing reservoirs, then we call it open loop and existing reservoirs. These can be built on the mine pits also. In the fourth case, you see, if you have mine pits, you can build convert them to reservoirs, build another reservoir, and use this technology. The greatest advantage of this technology is that you can supply all kind of power with use of these storage capacities of pump storage. Because they are long duration storage, 7 to 9 hours of storage, you can give 24-hour supply. During the day you store the power, and evening and night you supply the power. You can need power, you can supply power need based when you need high power. You can store during the day, you can supply more power during the evening and morning peak requirement when you have high requirement. And you can have bespoke use also. You can supply the power as and when needed. What I feel looking at the needs of the defense and other needs in the Andaman Nicobar, I feel since wind is also available in that area, the storage requirement from 8 to 10 hours of storage projects will be very, very useful for the Andaman and Nicobars. That is where I think it will satisfy defense needs also. We will give RTC green power, round the clock you will get green power. And when morning, evening peaks are coming, DISCOM and the local people can have additional power available from the pump storage project. So it can be combination of RTC and flexible supply, which is capability of the pump storage project to supply on a long duration basis. I think that is where the need is very well utilized for the pump storage projects. And as we said about the fluctuations and voltage drops, etc., I think all these problems will go away because these pump storage projects are very good grid assets. If you look at it, will smoothen the RE whenever solar is shining. You cannot have fluctuations because all fluctuations will be absorbed by the pump storage projects. Battery is also equally capable, rather better capable than pump storage projects, but that is for small durations only. Capacity firming, the pump storage projects are excellent. Batteries are also suitable. Frequency regulation, both the storage technologies are equally excellent for giving you the results. Voltage, reactive power requirements, which I think was discussed in an earlier presentation, pump storage can provide an excellent solution. So all these things, if you look at and ramping up and ramping down, all these capabilities are available. Batteries are slightly better than the pump storage project. So I think a combination of small quantum of battery and a bigger quantum of pump storage projects is a mixed bag solution which can ideally work for the Andaman Nicobar. And looking at the topography and the area, because there are a lot of water conservation areas in there in Andaman, but I think there's a possibility that you can provide all these.
Sorry to interrupt, but we have running short of time, and already you have.
This is my last slide. This is my last slide.
Okay.
This is what I wanted to say, that we can go for a big way for pump storage projects and maybe in a smaller extent in the battery to give a solution for the Andaman Nicobar. Thank you.
Sure.
If somebody has questions, I can take the questions.
Thank you so much, sir, for your knowledgeable and insightful presentation. Yeah, we can take questions at the end. Now, next we have Mr. Amresh Kakkar, Head Grid Technology, and Mr. Niket Jain, Chief Manager HVDC and Grid from Siemens, India. They'll be sharing their extensive experience on how we can explore feasibility of transmission infrastructure for green power from mainland and within the islands. Please, you can start your presentation.
Yeah, hello. So, good afternoon to everyone. I am Niket Jain from Siemens Energy, and along with me is Mr. Amresh Kakkar. We are both from the Grid Technology division in Siemens Energy.
Mr. Jain, sorry to interrupt. Mr. Jain and Mr. Kakkar, due to paucity of time, if I would request if you can kindly limit your presentation to 5 minutes, please.
Sure. We do that, yeah.
Thank you.
So I'm just trying to share my screen. Could you please confirm if the screen is visible?
Yes, the screen is visible now.
Okay. So, let me just come to straight away to what would be one of our recommended solution to the problems cited by the various speakers. I think Ms. Deepa Nair spoke about it. Another gentleman also spoke about it. So the solution that we would propose is that it would be technically feasible to connect the Indian mainland to the Andaman Island to an HVDC interconnector. So on the left side, let's say we have a lot of renewable power, or anyway a lot of excess of power on the Indian mainland side. On the left side, you see this. And on the right side, let's say there is a potential of RE power being developed in the Andaman Islands. It could be solar power, it could be offshore power. One of the speakers talked about this. Currently, the island's own needs might not need that much of power, but once this interconnector is established, then the mainland and the Andaman Island are interconnected. So the RE power from the Indian mainland could be transmitted to Andamans. And when Andaman Island is having RE power in excess, it could transmit this back to the Indian mainland. The system permits bidirectional flow of power. You can also control the amount of power that you want to exchange between the mainland and Andamans. Capacities from 0 to 500 megawatt. So when you have only 250 megawatt or 50 megawatt of generation in Andaman, you could transmit back to India, or and vice versa. It's also a firewall against disturbances, so that's one of the unique features of an HVDC. If there is a disturbance on the Indian mainland side grid or on the Andaman Island, then both of them are isolated from each other because of the fact that there is an HVDC. You can use long distance cables for these interconnections, obviously, because it has to be used in the subsea. So AC cables are not very helpful in such cases because there is a serious limitation that comes in after just 50-60 kilometers, but an HVDC cable can go up to significantly high distances. There was some talk also about voltage variations and disturbances and variability of generation also causing some voltage fluctuation issues. So the VSC technology that is used has an inbuilt STATCOM, which provides dynamic reactive power support and can also support the grid on both sides, the Indian grid, of course, but also mainly on the Andaman Island side. And I think the more important thing, which might be also interesting, is that it also has a black start. So in case, for example, there is a blackout of some nature on the Andaman side, then the Indian mainland can feed the power from the HVDC and power up the island grid. I will not talk about so much the solar PV potential is someone for the generator side to say, but what I would mention is that we also have offshore grid access solutions where we supply offshore substations, both AC substations and DC substations. So say example, you set up a 100 megawatt wind park or 50 megawatt wind park or 250 megawatt wind park there, then it would be possible to evacuate this power using an AC platform using 220 kV AC cables. So these could be not too far from the Andaman shore or the Nicobar Island shore, and then from there bring it to the main island, and from the main island send this power to the Indian mainland. This also one of the speakers mentioned it, and I'm grateful to that speaker for mentioning it. So this was a presentation in the G20 seminar, and as you know, there is also a plan to connect Andaman Island to Singapore via again a subsea cable link. So this is another potential where energy, if generated in Andaman, would have at least takers both on the Indian side as well as on the Singapore side. Since it's a knowledge, I had just mentioned what is an HVDC. It's basically something that converts AC into DC at high voltage. So the college students might have been interested in this, but as mentioned by the moderator, I'm skipping all this and going forward. We have done a project already using the VSC technology. It's the state-of-the-art technology in the world today. This is the first and only HVDC-based, VSC-based HVDC in operation in India, where we are implemented a link of 2,000 megawatt from Puglu to Trichy using overhead line and underground cables. Some pictures of the site, Puglu and Trichy. So this is what a converter station would look like if implemented in Andaman. A lot of preferences, so it's not something that we are doing new or for the first time. There are dozens of projects which have been done by us using submarine cable. Some of them are, of course, cross-country. So consider England as an island, Ireland as an island, similar to Andamans, and you can see that there are so many interconnectors built using subsea cables of quite high capacities, yes, going up to 1400. You also have island connectors, for example, Greece to Crete. So this is something like India to Andaman. You have Italy to Sicily to Sardinia, again like India to Andaman, all possible using the VSC. There is another technology which used to be there, that was LCC. So just for sake of completeness, I've also mentioned this. So LCC also was possible using HVDC, but this is currently now approaching obsolescence and not considered suitable for RE. And I'll end with this. So I think people are normally interested in which is the largest, which is the longest, which is the deepest. The longest link in operation is currently the Viking project, which we commissioned last year. It is having a cable distance of 740 kilometers. Of course, the Andaman Island to Indian mainland is much more than this, but that's not a technical issue. We are also implementing the deepest transnational link. So this is in Italy, connecting the islands of Sardinia to Sicily, which is going up to depths of 2,150 meters. And there are also projects where we are involved from the converters perspective for connecting Israel to Cyprus to Crete to Attica using the Crete-Attica link you saw earlier, and also to Africa. Yeah? So these are the Euro-Asia, Euro-Africa, where the depths are planned as deep as 3,000 meters. So, as far as the converter technology is concerned or HVDC is concerned, there is a solution, a well-matured solution available for you, and we are happy to support this with the government authorities. So, with that, thank you so much.
Thank you so much for your knowledge in the subject is truly admirable. Thank you once again.
Moving further, I request Mr. Devapam Chakravarti, Manager Emerging Business Energy KEC, to share insight about a small modular reactor for Andaman Nicobar Islands clean energy demands. Please, sir.
Thank you. Thank you so much. Am I audible?
Yes, sir.
And is my presentation visible?
Yes, sir, it is visible.
Thanks for having me. We'll just start with the topic. Just a second. Yeah, my presentation is visible, right?
Sir.
Yeah, so today I'm going to talk about the small modular reactors, which is a very promising advancement in the nuclear technology that has the potential to kind of revolutionize the energy sector. The SMRs are essentially smaller versions of traditional nuclear reactors, but come with a host of advantages and have definitely a few challenges. But given their mention in the recent budget announcement, it has particularly become important to discuss SMRs and their potential impact on the energy future. So most of the panelists, what we discussed was something which is doable in the right now time frame, right? However, this is something which is slightly more long term, maybe say probably 2 to 5 years down the line, but nonetheless extremely important and kind of revolutionizing way of looking at our energy needs. So before we dive in, here are the agenda points. We'll first discuss, we'll do the introduction to small modular reactors, then we'll discuss the pros and cons, and then the recent budget announcement, and then what are the benefits for the Andaman and Nicobar Island. Just a sec. Sorry. Yeah. So now what exactly are SMRs? SMRs are, like I said, advanced nuclear reactors with a power capacity of up to 300 megawatt per unit, about 1/3 of the capacity of traditional nuclear reactors. So these are designed to be small, modular and factory assembled and then transported to the sites for installations. So, it inherently comes with a lot of advantages. The first being safety. Since these are smaller in size, it's much safer than the traditional nuclear reactors, which have a lot of inherent challenges with them. And due to their smaller size, a lot of the nuclear fuel which we are using, that is quite less, which consequently lowers the potential radioactive release in case of an accident. So twofold, it is safer than the traditional nuclear reactor. Secondly, it is very cost effective because the modular nature of it allows for the factory construction and reducing cost and construction times compared to the traditional reactors. Thirdly, it offers a greater flexibility because these can be deployed in remote locations or areas with limited grid infrastructure and providing reliable power where it's needed the most. And obviously the prefabricated units can be manufactured and then shipped and installed on site, offering savings in cost and construction time. Lastly, the benefit is that it's scalable. So something like for the use case of Andaman and Nicobar, SMRs can be integrated into existing grids or deployed off grid. And as and when the use increases, we can scale it because of its modular design. And I've already touched upon the fuel requirement point that SMRs So they require refueling every 3 to 7 years, or even lesser refueling required compared to 1 to 2 years for conventional plants. So you don't have to worry about the fuel refueling in and out of the island. It obviously comes with few challenges. The regulatory challenges which okay, my slide wasn't moving. So the regulatory challenges are right now everything is designed around the nuclear plants, the regular nuclear plants. So we need to kind of make a framework specifically for SMRs. Then we still are working. There's a public perception that there is some level of skepticism and concerns about nuclear safety and waste management. So we need to work towards that to ensure that we do not get into regulatory hurdles once we decide that we want to do this project. Now, coming to the interesting aspect that in this 2024 budget, there was a lot of buzz created around SMRs after the mention of SMRs by our finance minister. So the government has allocated funds and funds for the research and development of SMRs, recognizing the potential to enhance the country's energy security and reduce carbon emissions. Under the outlay of major schemes, around 2,000 crore has been allocated for nuclear power projects, with the mention that majority of it is going to be towards the development of SMRs. Secondly, the finance minister emphasized the importance of collaborating with the private sector to advance the SMR technology, including setting up of something called as Bharat Small Reactors, which is nothing but SMRs, and focusing on the R&D of these Bharat Small Reactors. Thirdly, regulatory framework. Steps are being taken to establish a streamlined framework specifically tailored for SMRs, which we don't have today. Fourth point which was mentioned was the government plans to initiate pilot projects in various regions, especially in remote and underserved areas, to demonstrate the feasibility and benefits of SMR. So here is something which the ANI administration can look into. Because definitely this is going to phase from a pilot stage only, because even the global references of SMRs still are in double digits only. Lastly, skill development, because we are going to build so much, we need to have a workforce capable of supporting the design, construction and operation of SMRs. Last point is the benefits for Andaman and Nicobar Islands. So given the unique challenges which was already discussed by a lot of the panelists, SMRs offer specific benefits. First is energy independence. SMRs can provide a steady and independent power source for the island, reducing reliance on imported fuels and improving energy security. I think Dharmendra sir was also pointing out to these issues, which absolutely can be solved with SMRs. Second is, obviously SMRs are off-grid, so making them ideal for remote islands where extending the main grid might be impractical or too costly. Although the cost factor of SMRs are still under works, but it is expected to be cheaper than the extension of main grid or deploying the conventional solutions in the island. Third is environmental impact, because SMRs take less space. They significantly reduce the carbon footprint of the island and replace the whatever DG gensets, whatever conventional power what we are using. Globally, for reference, we have around 80 SMR designs which are in development and which target diverse application. I would like to highlight one specific application of Russia, where they have built a floating nuclear power plant. It's called Academic Luminoso, and it is the world's northmost power generating plant, and it's on a boat, and that boat is capable of moving from place to place. Right now it is harbored near a city where it is providing with the lighting and heating needs of the city. So the use cases of SMRs are right now, we know of a few use cases, but going forward as SMRs develop, many more use cases might come up. which potentially have the, which can revolutionize the energy sector. That's it from my side. In summary, we see a lot of promising advancement in nuclear technology, and this focus is going to be on SMR, and the government has showcased its efforts towards SMR. So next 2 to 3 years are going to be interesting. In 6 months' time, the Finance Ministry is also going to release another report where it details the budget, how what percentage is going to go into what section. So we'll get more details on that, but definitely an interesting times ahead for SMR. Thanks. Thank you.
Thank you so much, sir, for sharing expertise with us. Moving to the next presentation, our speaker, Mr. Ravi Verma, Senior Vice President, Avada Group, who will be discussing the crucial topic on harvesting renewable energy technologies. With a wealth of experience in the renewable sectors, Mr. Verma has instrumental in driving innovation, solution and strategy at Avada Group, a leader in the renewable energy industries. Sir, please. Ravi sir, are you there?
So we can take the next presentation in the meantime. So our next presentation is by Mr. Sunil Nair, founder and CEO of Magic Mina. He'll be sharing his expertise about mapping the ANI geography for renewable energy installation in Andaman Nicobar Islands. He'll also share his insight virtually. So Mr. Sunil Nair is welcome.
Good afternoon to the fraternity. I would not have a presentation keeping in time the time limitations. Most of the points that have been covered, the gaps have been discussed from both the government side and the other stakeholders from the industry too. So I would come from the support side of the infrastructure. So primarily Magic Mina is a UAV or a drone entity, which is the TOT partners with National Aerospace Laboratories India. And we specialize in a variety of applications, including infrastructure monitoring, which includes, asset monitoring, which is primarily something which I see a great scope in the ANI. This would include 3D mapping of potential site locations as well as existing infrastructure asset mapping, which I now understand that there are hydro-based projects there as well as solar-based, which needs to be constantly inspected for their, effective performance. This is one area. The other possibility is also the potential for the coastal mapping, which can monitor, in terms of the what I would say is the plan for the coastal defenses as well as other areas, which includes because of the continuous possibilities of soil erosion in the coastal regions. So to assess the infrastructure as well as the potential locations of the infrastructure will be a very an area where we can definitely contribute in a large manner. In addition to this, of course, these being multi-purpose or dual-use technologies, it could also be supporting in terms of the environment monitoring, which is a very critical part of the ANI system, because basically I also hail from a place which is environmentally sensitive and which has been continuously facing similar issues. So it is very much critical for us to ensure that the upcoming technologies, the infrastructure also caters to the environmental outlook which we have at this point of time. Further to this, we would also be able to provide live infrastructure inspection in the future once it comes into play. This can include project monitoring. This can also include monitoring of power lines or the allied systems. So there are a variety of applications which can actually be as a support infrastructure, which we will be able to provide to all the stakeholders once you put this into place. So I do not want to take more time on this. I am available at Sunil at magicmina.in, magicmyna.in. So keeping in line with the time limitations, I wouldn't take much time. I would also like to tell you in this platform that we are presently working on a hydrogen fuel cell based UAV, keeping in mind the sustainable solutions in these places which include the ANI. So, so that anything regarding this, we are very much on board to support the ANI establishments. So, thank you for that.
Sir, thank you so much for your insight and your informative presentation. Now, if Mr. Ravi Verma is there online, we can have his presentation, or unless we can start with the last presentation of this session. Mr. Ravi Verma, if you're connected online, as we continue our session on sustainable energy solutions, it's my distinct honor to introduce our next speaker. We are so much privileged to have with us Vice Admiral Dinesh Prabhakarji, AVSM NM VSM retired, Distinguished Chair of Marine Engineering at INS Shivaji, who will share his insights on the possibilities of harnessing nuclear power in Andaman and Nicobar Islands. He had an illustrious career in the Indian Navy, serving with distinction in various capacities. He has been awarded the Ati Vishish Seva Medal, now Sena Medal and Vishish Seva Medal, for his exceptional service and contributions to national security and strategic planning. Today he will provide us with valuable perspectives on how nuclear energy can be harnessed to meet the unique energy requirements of this region, contributing to sustainable development and energy security. So we welcome Vice Admiral Dinesh Prabhakarji.
Thank you. Good afternoon, ladies and gentlemen, boys and girls. Today I'm going to talk about harnessing nuclear power for Andaman and Nicobar Islands. I understand I'm the last speaker, and the responsibility is for me to make up for the long time taken by the previous speakers. So I'll try to be as short as possible. About 4 years ago, a committee was set up. It was set up by Chairman of Atomic Energy to find out feasibility whether it's possible to provide nuclear power for Andaman and Nicobar Islands. I had the privilege of chairing that committee, and at that time there was full support from Andaman and Nicobar administration to the extent that then Power Secretary Mr. Mahajan and Superintendent Engineer Electricity Mr. Ajit Kumar, they had come down to Delhi to my office to give all possible inputs, and we are very grateful to them. Even Lieutenant Governor, he rang up a couple of times to expedite the matters. Today I'm going to tell you what was the outcome of the committee and why there was no action thereafter. What are the benefits we can derive from the present union budget, as was being mentioned by the previous speaker. These are the figures given to me that time. So these are little old, but today morning, Madam Deepa Nair, she updated us, but it's not very different to what I'm going to talk of, what is possible to be provided and what will be useful to Andaman Nicobar Islands. What has to be seen is also in this slide that during the daytime, there is a lot of extra demand for the power, and in the lean period, possibly at night and other times, it is less. And if there is a power plant which has load following characteristics, it will be much better. Now, load following characteristic is that the power produced is equal to what is required, because otherwise the thermal power plants are the ones which produce some electricity, and the rest of it, when not needed, is not utilized. So it will be better if you can produce only what is required. And as mentioned earlier, some defense establishment over and above this have captive power. I think 16 megawatts is what was mentioned. At present, all the electricity that we produced here in mainly by the diesel generators, as mentioned earlier, and all the diesel is brought from the mainland, and therefore it is expensive. Small amount of hydropower, 5.25 megawatt is there. Some solar power is also available, aggregating to about little less than 30 megawatt, as mentioned earlier. But since the weather in Andaman Nicobar is not conducive to solar, and also storage problems of the present problems of solar energy, the usefulness is limited in this region. At present, it is surprising to find out that the cost of transportation, cost of diesel, etc., is 42 rupees. That is actual cost, though it is being sold to the domestic users up to up to rupees 6, even lesser to smaller users per unit, and for commercial use it is 15 rupees per unit. Also, one of the major requirements of Andaman Nicobar is going to be that we want to have a container transshipment terminal in Campbell Bay, near southernmost portion of Andaman Nicobar Islands, and the power requirement of that is going to be about 50 megawatt. Why that is important, I like to highlight in next few slides. This is the shipping route in the next in this part of the world, where all the cargo is generally come into this route. But since we do not have any transshipment facilities, so either is done at Colombo or Singapore. So losing out economically quite a bit because of that. And if we have that transshipment port at Campbell Bay, it will be big benefit economically for the country. And further to that, the location of Andaman Nicobar, especially so the southern portion of it, is very strategic because it's overlooking the Malacca Strait. All the ships, whether warships or otherwise, when they go pass through it, one can monitor actually if from Campbell Bay. This slide shows that the southernmost portion of Nicobar actually is overlooking the Malacca Strait. So hence the strategic importance of the place. You may have heard that Sabang in Indonesia is a port that is being of interest both to India as well as China. And they want to develop that. And it's just about less than 200 kilometers away from Campbell Bay. And if we are the first ones to do it, then Sabang loses its charm, and vice versa. So we have to be quick to implement this program. So as I mentioned, in addition to economic reasons, strategic importance is there, and the power requirement of this port is about 50 megawatts. And now, how to meet this requirement? The previous speaker had mentioned small modular reactors. The definition of small modular reactors is less than 300 megawatt. We already have a standard 220 megawatt pressurized heavy water reactors, which are spread across the country. So if such a reactor could be put as it is without any change in design in one of the uninhabited islands, and a power grid could run across the habited islands, including Campbell Bay, it will be very useful. estimated cost of such a project would be about 15 crore per megawatt. This is proven and no further development etc. is required. But this or any other small modular reactor has got some problem in this region. The main reason is that Andaman Nicobar Islands are close to earthquake active fault trace, and it is also tsunami prone. That's a big problem for not only this type of reactor, but any reactor, nuclear reactor that is that's planned to be put here. This is earthquake hazard map, and you may notice that earthquake in the region of Andaman Nicobar have been occurring earlier also, and there's a activated fault trace which is just along the lay of Andaman Nicobar Islands, and epicenter of course a little south but not very far from the southernmost portion of Nicobar, and hence the problem. The tsunami which came in 2004, this is what how it acted out, and it is possible it can happen again. So one has to guard against both earthquake as well as the tsunami, and therefore to set up such a nuclear reactor, Atomic Energy Regulatory Board will have lot of difficulty in clearing it. You may know that in countries like Japan, which are also earthquake prone, which also have tsunamis, there are nuclear reactors already functional in a number of places, of which it has to be hardened for earthquakes. And it's possible to do it. Even there is no further technology required, it's available. But the cost of that goes up manifold, and even after that, to get it cleared by present Atomic Energy Commission Regulatory Board, it will be extremely difficult. But there's some way out. As mentioned by Mr. Chakrabarty earlier, this is a Russian floating nuclear power plant. This is located near Siberia, and they have done it to cater for a large amount of electric power that is requirement is there for mines. There are a lot of mines there, so ores are a necessity to Russians, and therefore they have to build such a nuclear reactor at some remote place rather than running a grid all across to new location. Russia is very keen to give this technology to us. Not only Russia, even United States has shown inclination. They don't have such a reactor, but they would want to give a small nuclear reactors technology to India. But do we need it? There is a, in continuation of what I just mentioned about the floating nuclear reactor of Russia, tsunami has no effect, earthquake or tsunami has no effect on a floating object if the depth of seawater over there is 100 meters or more. And fortunately in southern part of Nicobars, and especially on the western coast, the sea depths are much larger sea depths are available, and that too very close to the seashore. And that advantage is that we can draw the power from there, even at a distance of let's say 1 or 1.2 kilometers from the shore, and there will be no issue. Now this is the thrust that I wanted to highlight in today's presentation. We have developed submarine nuclear power reactors in the country. Already existing nuclear power for the submarines is available, technology is available, the reactor itself is available. Such submarines, we have been running it for last 3 to 4 years. Another one is getting commissioned soon, and therefore we don't have to depend on any technology from Russia, America, etc. This is readily available and can be utilized by us for Andaman Nicobar Islands. And what we propose is that we should have instead of one but two such floating objects, because in case of refueling or any other problem, at least one is available. And their capacity, electric, 126 megawatt electric, both put together, can be made available right away. Right away means you have to order it and it will get manufactured. But there is no R&D required at all. The advantages of such reactors is that they are compact and very useful if it is a floating type. No further development required, and very importantly, they are totally indigenous. No import content at all. 100% indigenous it will be. And we can go to the same vendors who had been done earlier, so that much faster it would be. And as mentioned earlier, it has got load following characteristics that will save energy as they be produced. But here again there is a problem of cost, and cost only of the initial cost. These reactors which have been made, they have been made actually for fighting a war. That means the submarine, even if there is an explosion nearby, it won't, nothing can get affected. That the whole thing is costing about 60 crores per megawatt, which is extremely high, which actually, when we do it for requirements of like Andaman Nicobar Island, we need not harden it, because we not actually not for fighting a war, it's only for providing electricity, and therefore the cost will come down. It will come down from this. But that's only the initial cost. Actually, for any nuclear power, initial cost is very high, but the running cost is quite low. That's true for any nuclear power plant. Just to give an example, Tarapur nuclear power plants 1 and 2, which are in at present producing electricity also for us, the cost of production is as low as 92 paisa per unit. I need not give any more arguments. This is what, if it can produce it, even the lifetime cost of it, of the reactor, actually pays off as the time passes. The life of these reactors is typically of the order of 30 years or more. And in this case, it's not a moving one, so perhaps it will be even more. So the question being asked is that can nuclear power be harnessed for Andaman Nicobar Islands? Yes, it can be done, but it's a costly proposition as well as initial cost is concerned, and that is why it didn't fructify when these reports were submitted to the government few years ago. But as mentioned but previously, that present government has announced incentive to for this. Some budget allocations have been done quite liberally, and they have said that we can partner with the private industry. At present, there's a Act of 1957 which says that nuclear power can be generated only by government agencies. So that will have to be amended. But since it has been proposed by government, I suppose that will take place. And having got this money for such reactors, I think it is opportune time that we should bid for, Andaman Nicobar should bid for it, and it will fructify. Thank you.
Thank you, sir, for sharing your profound insight and for your unwavering commitment for advancing energy solution for our islands. Thank you, sir. Now I request Brigadier Ashish Bhattacharya and Sri Shankar Rao, sir, to present a memento to Vice Admiral Dinesh Prabhakar, sir. Please, sir.
If before we go for the memento presentation, if any question answer session is there, because the session is off, we had said that the question answer session will be at the end. So before we conclude, please, sir. Any questions? Because I think online speakers are also there. Any questions from the? Yeah. So,
Sir, you have talking about the OTAC, Ocean Thermal Energy Conversion. In 1987, I read a paper of the Manoj Singh Saab will also be aware of that. I think IIT Madras, they had done some studies. That is near Chidiya Tapu, Brother Sister Island and Sink Island. I think there is a potential of about 35 megawatt, and it is a good source of energy, continuous source of energy, whereas wind and solar, they are fluctuating. But once we go seriously work about that, I think that will be very good. This is my suggestion. I think defense is, you told that you are doing some R&D.
We are looking for this opportunity.
Okay.
And it's not only that OTC in combination with desalination plants.
That is a multi-purpose project. You can get the water also, you can get the hydrogen also, and blue-green algae also.
We got this project report, and then we can work on it.
Okay. And my another thing was there about the this thing biomass. Our Nicobar group of island, completely their economy is dependent upon the coconut, and coconut shell in abundance it is available there. There are some good industry like our reflex industry, Mr. Shamal Chaudhary is running in Hut Bay, Campbell Bay, and Port Blair also. There were some projects initiated by electricity and some tendering was also done. Because this coconut shell is having very high calorie heat, it is available and it is not utilized, and then that project has gone. I think if we implement that, that will be very, very useful.
So all kind of these things we have gone.
This is my suggestion to Renewable Energy Department also to properly utilize the coconut shell potential, which is easily available in abundance in especially in the southern group of island, and of course in middle north it is also there.
Definitely defense is open to this, and we are going for the consultancy. If anybody is interested, they can bid for it. And based on the consultancy reports, we are going to implement it. So OTEC is one of the best. We have got 5 desalination plant is running in this installations. So we are looking for this opportunity.
Thank you, sir.
Sir, actually we have a report from Tamil Nadu, some agency has conducted. In that report it was mentioned like after 3 years this biomass availability will be completely exhausted. So after that we didn't proceed further.
The coconut shell will be...
No, it should be continuously available. Coconut and palm trees were there earlier.
Coconut is total economy of the Nicobar group of island is dependent upon the coconut itself.
Yes, sir, but sufficient quantity is not.
Sufficient quantity is available, madam.
Okay, we will ask them to conduct the
I
study
studied
once
from
again.
class 2nd to 10th in Nicobar, and frequently I visited those islands. I have seen that is going west.
Okay, sir, we will ask the firm to conduct the study once again.
Forced, but that is not that heat which is produced in producing charcoal also not utilized.
Sir, question to you, sir. Wind energy, you said, which location has the study been done? Any study been done? Which place, sir?
We will share that. There. Camel Way we are trying to get this. Camel Way. In Camel Way we are trying to get it. This wind energy.
Already electricity department has done a lot of studies on wind. Some 12, 13 locations they had installed that and I also seen the data. It is in
I'm personally privy to
Hawk
it.
Point in Nicobar. In Kamota, one place is there, I don't
We
remember.
are trying to that.
No, no. I thought you would have done some
Vikas
study.
Nagar.
No, this is based on the report
Hawk
which has
Point.
been already
This
done.
is available. Good potentials are available in these three
See,
locations.
I am privy to this. In Dehradun, we have installed these two projects, this hybrid project, 2 megawatt solar, along with this wind. So that is very functional and it's very economical. So,
2 megawatt only.
yeah.
If wind that Hawk Point
We have got
and
3.2
this biomass coconut shell, I think we can fulfill the requirement of Nicobar.
It's actually 3.25. One of the main contender is sitting here. He is the one who is going to install this project. The project is right now is, we insured, he has insured me in this meeting only, like he is going to install that.
One clarification from Shri Shankar Rao, sir.
Yes, sir.
Sir.
Please.
You are having 330 kilowatt of rooftop solar plant here, sir.
Yes, sir.
Roughly around 19,000 to 20,000 units are being generated monthly,
Mhm.
which is meeting more than 100% of your requirement. Very commendable, sir. But the total generation is coming 330 in a one. It is coming 2 units per kilowatts.
2 units per kilowatt.
Whereas the standard for designing purposes is being taken around 3.5 to 4 units. Yeah. Why it is coming to the 60% level, sir? And all about the rooftop solar plants in Andaman and Nicobar Islands, we have installed many, around 5 megawatt. So what is the last 5 years performance? How many units per kilowatt is being generated actually in these islands? Because theoretically or at the time of DPR preparation, it is said it will generate around 3.5 to 4 units per. But in this case,
Yes, sir.
it is coming
We have
around 2
discussed.
units. So there is a fall of around 35-40%. So that is a very big steep fall.
Big steep fall.
And it will discourage future rooftop solar installers.
Sir, except for the month of February and March.
I'm talking of 20,000 per month average.
Energy only we are able to get out of 330 kilowatt power.
Sir, actually, nowadays we are mandating that 70% PR ratio should be there for all the solar panels which we are procuring, and CUF to be approximately 15%. And now, except for the NLC power plant, NTPC power house is performing well, and the CUF is nearly 14 to 15 in NTPC plant. But for NLC plant, the performance is really poor, and except for the month of March, we are getting 7, 8. In NLC power plant, except for the summer season, where the performance is really poor, CF is really less. In the DPR, they have mentioned 19%, but while executing the PPA, they have mentioned for 15.33. So right now, in March only, we are getting 12% CF.
Okay. DPR, it is 19%.
19%.
It is actually coming 15%. In this case, it is
15.33 in PPA.
In the PPA.
But, only for the month of March, it is giving 12.
12%, March only.
Yes.
In this case, it is coming 9% on an average.
Sir,
still coming down. That's what I am saying.
Sir, can I say something?
Sure.
Please.
Whatever the panel has been installed, sir, their inclination is not as per the latitude and longitude. And wherever they got the place, they installed. It is not as per the proper direction, latitude and longitude. You will agree with that, Deepak?
Yes, yes.
Yes, it may be.
So naturally the generation will go.
I never wanted to point out, pointed out. I
You
wanted to
can,
know
you
why
can
it is
see
happening.
one small beautiful example in Golgas recently that police, what is the direction of the panel and what is the inclination. That is small. This thing.
It should be southeast.
Okay. What I would suggest.
Yes, sir, please.
The rate and the department, there are so many rooftop solar plants, new persons are not coming to install it. Maybe because of higher cost or not satisfactory performance of the earlier installers. They could do a study of this.
We will take a study as a student
rooftop
project.
solar
sir.
plants as a student project. Na?
Yes,
It will be good for them to also learn. And then you will come out with a figure how much you are actually generating, and you could tell the people, new customer, new buyers, that you are generating. Because this figure of 2 units per kilowatt seems to be quite low,
Lower side.
quite low on lower side.
Sure, sir.
To the Department of Power, sir. You had stated that the 50 megawatt LNG plant. The Honorable Prime Minister has laid the foundation stone for the Hopetown plant, and Petronet has come forward, NTPC had come forward, Ministry of Power had also sanctioned. Now you are saying that it has been closed. Whereas Great Nicobar is proposing to set up a 450 megawatt LNG plant.
Yes, sir.
Ah.
Great Nicobar, it is still in the pipeline. But for other islands, that 50 megawatt what we have proposed for Hopetown, that has been dropped down. In the advent of this 118 megawatt under the greening of islands, we have proposed 60 megawatt for Stewardganj. 60 megawatt for Stewardganj, Mitakadi 40 megawatt, Nicobar group of islands is still there. So totaling to 119 megawatt has been proposed. So for optimum utilization of these resources, when it is coming, we won't be able to use that effectively. And this renewable energy is obviously free of cost. So there might be a probable reason for dropping down 15 megawatt LNG.
But unfortunately, a project for which foundation stone was laid by Honorable Prime Minister is being not implemented. And number two, the LNG plant is a load following plant, as Admiral Sir was saying, whereas the solar plant is not a load following plant. It will be available during a very limited period of time, during the day only. LNG gives it 24/7, this provides. So I could, as they are putting up a LNG plant in the Great Nicobar Island, I could suggest that this could be retaken up.
Okay,
One
sir,
more thing you are telling about a pump storage plant at Kalpong.
Yes, studies are going for feasibility.
How you will pump the water back to the...
Through renewable energy source. Actually, we have identified land at Nabakra area. So we will install some 4 megawatt of ground mounted solar power plant for pumping it.
With the solar plant, it will be available.
Yes. Thank you.
Thank you.
Any more questions from the audience? Students, participants, delegates?
Thermal power project. Speakers can also ask questions.
Surely, sir, sure. All is yours.
I have two questions. One is that the gentleman who were telling us about undersea cable. What's the cost of the cable? Our project will cost how much if it has to be brought from mainland to...
I think the online speakers are there, the virtual speakers are there. This question is for them.
And the process. We are not cable manufacturers. I mean, it's a valid question. What we are supplying are just the converter stations on both sides. Just one more. On a global scale, typically these
Sir, please switch on your camera, sir. Please switch on your camera. Sorry, thank you.
Okay, give me a minute.
Mr. One more thing I want to add over here.
Hello, am I visible now?
Inspection of all the items.
Yes, sir. Yes, sir. Please go ahead, sir.
Yeah, so the HVDC scheme that I talked about as having two converters and an undersea cable, right? So what we provide from Siemens Energy are the converter stations. The undersea cables are provided by various manufacturers. We currently do not have any HVDC cable manufacturing in the country that I'm aware of. So CA, CTU and Ministry are in dialogue with the local cable manufacturers to upgrade their technology and manufacturing to be able to manufacture HVDC cables. Most of the suppliers are located in Europe, and there are some also in China and Korea. I mean, I would be giving a very thumb raw figure here, but it's typically the cost of an HVDC cable is in the range of $1 million USD per kilometer. So it's expensive. There's no doubt about that.
And also cost of laying the cable also adds to it.
Yes, of course. So the interconnection, I mean, can be done. The question is, of course, the cost is going to be prohibitively high. It's not going to be a cheap solution. Yeah. So it has to be probably funded through strategic reserves, or it has to be considered as a strategic project for the country. Uh, it's probably the cable itself, so just because of the distances involved between the mainland and Andaman. It's quite likely that the cable will be the significant part of the project cost, not the converters. As far as I know, the terminal is planned at somewhere near Paradip in Odisha, on the Indian side. And I'm not aware of the specific location on the Andaman Island or Nicobar Island where the terminal will be located. But yes, we have been part of discussions with the CEA, CTU, also Power Grid, and various others who have been discussing with us. And as I said, the feasibility of the project actually would depend on the availability of the cable and the economics of the cable itself.
I just wanted to prove that. My case of a nuclear power plant, floating one, may be cheaper than this.
Might be, yeah. So we actually had proposed that as long as the connectivity to the mainland is not the main topic and it's only making power available to the islands, if that is the motive, then installing a renewable power source within the Andaman Nicobar Island is a far more cheaper solution. So you can put in wind turbines, as some speakers have spoken, you can put offshore wind turbines, you can put solar, you can put all sorts of localized energy sources and feed the islands. The question comes that is there a rationale or an intent to connect the islands to the mainland? If that is there, then there is no other way other than using a cable, whatever be the cost.
Thank you.
Thank you.
Another question, one more. And ma'am, everybody is asking questions to you, so I won't be exception. It is in continuation of what we talked during the tea break. We just gone through the site of SBI. SBI provides a loan to an individual who is willing to install a solar panel on his house. And it has been announced that they'll assess, at least in Delhi, I know for sure, that somebody comes and assesses that what is the requirement of that house, and they would install a panel slightly more than the requirement of that house, including what he needs during the day and what he cannot generate during the night, because storage is not planned for that. So what is being thought of is that this loan that SBI will give to the individual, the amount of EMI he has to produce, he has to give every month, he doesn't have to give on his own. He will, whatever electricity he has been consuming earlier, that will be zero bill to him. What he gives to the grid will be the EMI to the bank. So he doesn't lose anything at all. It's free for him. And after 4 years, that's what they have calculated, he'll start getting money rather than, and free electricity in any case. So actually it's a win-win situation for everybody. If such rooftops are there across the country, millions of them, then we're generating electricity for free for the individual and actually for everybody else also. And I think state government will have to be part of it, because it may not be central alone who will be doing it. I'm not sure about the last part, but I think we should work towards that. And free electricity for everybody is quite a boon.
Okay, sir. In the next, actually, Chief Secretary Andaman Nicobar Administration is taking a review every week on Wednesday. So during that power review meeting, I will raise this issue, and so that we can have a collaboration with SBI. Like if any other states are following, we can adopt the same procedure. Okay, sir.
Hello. Mr. Siddharth Mayur, talking about hydrogen energy, was saying about clean cooking energy, clean cooking with the solar panel and battery and induction stove. The power department has also installed around 99 induction stove with solar panel, battery, inverters, charge controller. in Choldari, which was also inaugurated by the Honorable Prime Minister during 2018. This could be also encouraged in this island to other households for getting a clean cooking energy. And before that, if the study could be done and the people, stakeholders could be told about the performance of these 99 solar cookers with the panel, with the battery, with the inverters and induction cookers in the Choldari tsunami shelters, I think, the tsunami shelter. And again, in the college and the students could take this as a project along with the power department. Are you aware about the performance of these solar cookers?
Sir, I will get the feedback. Actually, 2 years back, there were some few complaints. That was actually done by ESL through their CSR initiative. So that was done free of cost under the guidance of IIT Mumbai. So later there were some issues and they have trained and one representative of ESL is here who is carrying out the O&M. So right now, there were few complaints which we have attended, but I will get the feedback. But I have heard that some. So, but that is not covered under this 1 year warranty period is already expired.
This could be a good solution
Yes,
as a
sir,
clean
later
cooking
on-
energy for
yes,
these islands.
This we have taken that 99 tsunami shelters for converting that village as solar village. And under that initiative also we have replaced all the lights, fans, that conventional to LED lights and outdoor lights, then normal this conventional fans to BLDC fans. We have changed it, but the performance of BLDC was not quite well.
Thank you, madam.
Thank you.
Hi, ma'am. My name is Sushmit. I'm from CII. I have one question with regards to mapping. While we have already had a speaker, Mr. Sunil Nair, who had spoken about mapping of the archipelago to understand the harnessing capacity of the island. So that kind of extensive study, has it happened, and who has done it? Was there any consultant that was hired? I'm not going, but with regards to mapping of the island and understanding the harnessing capacity of renewable energy, including both storage, pump storage, obviously, BESS doesn't require any space. So pump storage, renewable energy, which is solar, again, floating solar, wind, understanding the velocity, wind velocity, how much is it offshore, majorly offshore, and some maybe onshore also. So that kind of study has happened, and if has happened, what is the generating capacity that you have found out?
During 2022, SECI has been appointed as the nodal agency for implementing renewable energy in these islands. So SECI has already conducted a study in all the islands and prepared a renewable energy plan for the islands along with NIVE, National Institute of Wind Energy, who has conducted the study at various locations, as Arun sir has already mentioned. So for the past to 20 years, they are conducting study at several places, and they have identified wind potential also. But due to logistic constraints, like in Mount Harriet, the transportation and shipment of wind blades, that is quite difficult. So they have dropped it, and moreover, that is that coming under environment energy conservation. So that was also dropped. Now NIVE, what they have suggested is we will not conduct any further studies in Nicobar group of islands. Instead, they will go for hybrid plant along with DG and wind combination. So they are in the process of floating the tender for Nicobar group of islands. So approximately 10 megawatt has been proposed at 4 locations of Nicobar group of islands. For solar, and wind, nearly 1 megawatt capacity at each island has been proposed. And regarding offshore, and also NIVE is conducting study. Actually, they got some potential. They were in the process of identifying land at Hut Bay, Little Andaman also, and they have installed wind mast at 3 locations now at Long Island, Shahid Deep, and here Manglutan. The 3 wind masts has already been installed and commissioned, and still they were telling that Shahid Deep has got good potential for wind mast.
And also, ma'am, just to add to it, I mean, it's a benefit for the house also. There is a company called Flywheel in Paris. I've got the opportunity to visit them. They give a solution to, transport heavy loads like wind turbines and wind blades from one point to the other. And they are also run by green energy through hydrogen. So they basically, it's floating balloons that would pick up the load from one point and then put it to the other point. So if that kind of a solution you require, I have the contacts. And also, I mean, like for anybody, if you would want to connect with speakers later on, you can connect with me, you can connect with Ashish sir, and then we'll be able to provide you the contact details with
Sir, I
everybody.
would like to add that we are following GFR and we have to float the tender through CPP only. We cannot give such products on nomination basis. So through open tendering, if somebody is coming as L1, then only work can be allotted for any power projects. We cannot directly give that somebody is having expertise in such field. We cannot give them directly. Yes, yes. The tender has to be prepared like that.
Any more questions from the speakers as well as from the listeners? I think the virtual speakers are also there. If they have got any questions, then the house is open. There's no questions now. Thank you.
So now we request Sushmit Roy to conclude the session.
I request Shankar Rao sir and Ashish sir to come on the stage, and also request Vice Admiral sir to come here to receive this small token of love from us. Thank you so much. Before Mr. Sushmit from CIA conclude formally for this 2 days conclave, I would like just to summarize the points which we have taken for this 3 sessions. I think the last session already has been concluded with this question answers. It was indeed a very good experience for all of us in Andaman Nicobar Islands to have this conclave with the help of CII for this, what we call the burning issues on water security, waste management, and of course the sustainable energy. Yesterday we had 2 sessions on water security and waste management. So we have concluded this with the presentations which were given by the industry as well as the unique problems which were presented by the departments and the industry as well as from the defense organization. So the key takeaways for the sessions for water was integrated approaches, collaboration for source providers, using advanced software and digital equipments and technologies to monitor and automate water treatment plants, IoT-based field testing kits, reclamation of submerged lands, and containerized desalination unit, which was a real good solution for remote areas like our islands. And of course, in waste management, the waste reduction at source, then intimate collaboration with government and industry, with community, people-centered approaches, crucial role have to be played by the academic institutions like JNRM or DBRATE for taking the whatever the research we can take, and then requirement of inventories for current and future demands in terms of solid waste management, industry and commercial help available, and success stories of mainland areas which can be implemented here. And of course, in the power, we had so good solutions which was available here, which we can implement in the pockets as well as for the general things. The people were from there who are already doing the work, and also from the industry. I, on behalf of DBRATE and CIA, really thank all the experts from local areas, people who are there in virtual, as well as from representatives from industry and everybody to be the part of this conclave. A very historical beginning has happened. Of course, we will be putting a compendium with probable solutions and the unique problems which has been faced with all these things, and the experts and the research organizations who have also participated. Of course, I'm leaving everything to Sushmit to thank everybody. But on behalf of BRATE, it was indeed a very enriching experience for us, all of us, for the academicians as well as for the students. Now, this is a beginning of a new era for us to implement technology, which is implementable in this unique area, in a geographically isolated area. So we are really thankful to CII for having this done here. And it will be a new thing for the students as well as for academicians to take the challenge forward. Thank you. Now the Sushmit Sridhar.
Thank you, Raji ma'am. Esteemed speakers, dignitaries present here, online, my colleagues, and DBRATE, the university. Thank you so much for joining us with CII, the administration here, to collaborate with us on this consultative workshop. Like you said, ma'am, this is the first workshop that we have done. We have come across a lot of issues with regards to waste management, water, as well as energy. A lot of ideas have come up. A lot of good deliberation has happened. So we look forward to continue to partner with you all, find out better solution that works for the island, and then, the goal is to transition from whatever hydropower we have to renewable energy. So the goal for the nation is 2070. For island, we can plan for 2050 or probably earlier. So those things we'll have to see. And definitely, like it is said, sustainability development revolves around and being environmentally sensitive, social development, and economic value addition. So with these I think I would conclude that I would not want to hold everybody for the lunch. And thank you so much once again. Thank you so much for hosting us. And we hope to be back again.
I request everyone to join for lunch. Thank you so much for being here. We will be in touch for the future projects as well as the future association. Thank you so much. Yeah, all the experts and guests are requested to come on the stage to have a group photograph, please. Participants and delegates from other departments may also join. Please come here, please. Ma'am, आप लोग भी आइए, please. The delegates and participants and nominees from other departments can also join us for a photograph. Please come here, please. Ma'am, please. Thank you, sir. Thank you so much. And a big thank you from CIA and Debrate to the IT team for making it happen so seamlessly. Thank you so much, Mohan and team. Thank you so much.